Bullshit, I can't hear you. Sound off like you got a pair.
Hey, what's up, guys? Missed y'all. All right, think I got everything. I swear, you take a couple days off from streaming, and I forget where every damn button is. All right, I think I got everything prepped up now. Think so. All right. All right. Let me see if the actual TTS thing works this time. I'm gonna test it out real quick. That's so weird. Like
Fight the planet!
did y'all hear that? Gumby, I just did a test. Did you hear it? No. What the crap? Shut up, baby. I know it. What is going on here? All right, let's do Gumby's test here. That didn't do it either. I did break it.
Bullshit, I can't hear you. Sound off like you got a pair.
You're full of crap. I know you can hear me. All right, let me try this one now.
Arno Gumby cheered 5 bits and says, "You broke it."
All right. We're getting somewhere. Yeah, you heard it, but I didn't hear it. Ah.
I'm back, baby.
Okay, I think I got it maybe fixed now.
Arno Gumby cheered 5 bits and says, test number 42.
Oh, that's really loud, though. Okay, let me adjust that. Actually, you know what? Don't do that. Oh, I just realized I didn't turn on something. It doesn't help that I had to take all my computers offline because I was expanding the backup battery. All right, let's try now. Let's get started. Now the camera's not showing up? Fucking Windows, man. What is going on now? It's all radio. It's all radio tonight. Dude. What the heck is going on? All right.
What, your mom buy you a pewter for Christmas?
Maybe she should have bought me a better pewter. Damn, this thing is messing up. All right, hang on. I gotta figure out why the camera's all busted. What is this thing set to? Hang on one sec. We will get to the news tonight. There it is. Why is that? No, why is that not working? Now it's working. I got no clue. I got no clue. Apparently I'm not enough of a nerd. Because everything just went to crap. Right before the start of the stream. Actually, it's probably just because I didn't test it out. I take for granted all the stuff working. It's like, oh yeah, you go configure it. You figure the configuration shouldn't change, right? They should be stable when you just reboot the damn computer. That's just asking far too much of Microslop. Oh man. All right, now it looks like everything's kind of working here.
Arno Gumby cheered 5 bits and says, test number 1337.
That is, unfortunately, not going to work. Hang on one second. I need to cancel. Hang on one second. Because that is a bit loud on there. You know what? I'll just turn it down like this. I'm going to drop it a little bit more.
RNO Gumby cheered 5 bits and says, time to say fuck it and switch to Linux, hee hee.
That's right. Hey, Conrad, what's up, man? It just does feel about that time, Gumby. It does. God, man. All right, let me get this news stories pulled up for today. So we got quite a few. Look at this. I only had like 2 earlier, and then all of a sudden today, these last like 6 came in. So that's not what I wanted. Hold on, where is it? And of course it opens in the wrong browser window. That's how it always works. Let's see. Where is this? Here we go. Now it'll open. All right, let's do this. Oh yes, that's what this one was. This was cool. So it has not been a great year for a lot of the firewall vendors, because especially FortiGate and Fortinet. Hack the planet. Hey 57, what's up, brother? So they've just been getting popped left and right. So this was an interesting one that came up from the guys over at AWS. Oh yeah, the link. Thank you for reminding me. There we go.
RNO Gumby cheered 5 bits and says, just switch to Streamlabs desktop if you want thing to just work.
It's not that I want it to just work, right? I want the configuration, once I make it work, to just work. I just want the configuration to stay the same. It forgets like audio interfaces. It forgets microphone settings. I mean, I don't know what to do with it. I don't. All right. This is absolutely bad design there, Microsoft. I love your little floating nav bar here. This thing is horrendous. Let's get rid of that. Let me clean up this page here a bit. I think I want that one right there. Goodbye. All right, there we go. Got my screen real estate back. All right, let's kick it off tonight. So this one was from the folks over at AWS, well, on Amazon anyway. And they said AI augmented threat actor accesses FortiGate devices at scale. This one's gonna be a fun one. Do better. How's the family? They're doing pretty good, man. Agent Zero got second place in his race this weekend. Now, granted, there's only 2 boys in his class, but his lap times actually were really good. They were only about 10 to 15 seconds off the other boy, and Agent Zero's clutch was smoked. Poor kid. This track had a lot of ups and downs. It was very hilly. And there was one big drop, and it came down into a hairpin, and then another big climb after that. Hey Darnock, thanks for coming online, man. Dang it, I still gotta fix the audio sounds. I apologize. I completely blanked on that. I'll do it after the stream tonight. But thanks for coming online, man. So yeah, but as he's trying to go up those hill climbs, he's just he's revving out the engine, and he's just not moving very fast. So if he had had good power, if his clutch hadn't just smoked out on him, I think he'd have been fine. He's still having trouble following the track. So here's what happens. Usually what's happening is they host these things, and they host them at like private ranches. So the races, they're at private ranches, they go through and they cut a new track. But then there's other racing organizations that do the same thing. And there's just trails from trucks and farm equipment that have cut tracks on the property. So if you're not paying close enough attention, it looks like the track should go one way when it really goes another. So they put up arrows and stuff, but it's real easy for you to miss those arrows, especially if you're a kid. So Agent Zero went off the kids track onto the adult track a couple times during the practice. And so he was fine during the actual race, but yeah, that's kind of what it's standard par for Agent Zero. I'm working on making sure he reads the track better. So, but other than that, his darn clutch, man. I got to go take his bike apart. Maybe see if I can do that tomorrow. Hey, Robo, what's up, dude?
RNO Gumby cheered 5 bits and says, yeah, I'm just trolling, hee hee.
I know you're just trolling.
Reach Chris Young cheered 5 bits and says, did I just break this biddies thingy again?
The biddies. It's funny the way now this is legally distinct. This is not Cortana. This voice I created and named Cortan. Nah. There's a difference.
Reach Chris Young cheered 5 bits and says, what if Amazon doesn't use AWS for hosting their company website?
They do. They definitely do. In fact, there was a story about, I think it was Amazon Prime, like Prime Video, where they went through and re-architected their entire structure from using AWS microservices to using a monolith, and cut their costs on AWS because the internal business units pay for that as well, right? It's paid out of their budget rather than being billed for it. and they cut their internal budget costs by, I want to say it was 70%. Maybe it was 60%, but it was about that. Do I sometimes stream earlier? Unfortunately, Conrad, this is the only time I can stream. This is after I've gotten the kids into bed and I've just kind of got the night. So as much as I would love to, it's not really feasible with my two sons running amok in the house. It just doesn't work. Otherwise, I'd be totally down for that. Because honestly, I was most happiest, I think, when I was crashing out around 9:30 at night and getting up at 4:30 in the morning to work out before I started the day. So.
Reach Chris Young cheered 5 bits and says, typed cheer 5 and all I got was this lousy t-shirt.
Oh, let's see here. All right. Well, let's kick it off, guys. Let's get started with the first article for tonight. So, like I said, this is from the guys over at Amazon. AI augmented threat actor accesses FortiGate devices at scale. Now, AI augmented just means they had some kind of agent kind of like helping out with that. So, commercial AI services are enabling even unsophisticated threat actors to conduct cyber attacks at scale, a trend Amazon Threat Intelligence has been tracking closely. Recent investigation illustrates this shift. Amazon Threat Intelligence observed a Russian-speaking financially motivated threat actor leveraging multiple commercial generative AI services to compromise over 600 FortiGate devices across more than 55 countries between January 11th and February 18th of 2026. No explanation of FortiGate vulnerabilities was observed. Instead, this campaign succeeded by exploiting exposed management ports and weak credentials with single-factor authentication. Fundamental security gaps that AI helped an unsophisticated attacker or actor exploit at scale. The activity is distinguished by the threat actor's use of multiple commercial generative AI services to implement and scale well-known attack techniques throughout every phase of the operation, despite their limited technical capabilities. AWS infrastructure was not observed to be involved in the campaign. AWS Threat Intelligence is sharing these findings to help the broader security community defend against the activity. Now, they've already made a pretty bold claim here, and I'm not saying it's wrong. I just wanted to know what was their evidence for it. They're saying this is an unsophisticated attacker. It's like, okay, you had me at they were basically exploiting and spraying and praying passwords. That's pretty much what you had me at there. Let's see, because what did they say here? They said, yeah, they were going over exposed management ports with weak credentials and no multi-factor authentication. So, okay, cool. Now, the fact they used an AI to help with this, I want to see, one, what is their evidence? And two, kind of who gives a damn? Because you can do this with off-the-shelf stuff really simple. If nothing else, all the AI did was keep them from having to go script it out. That's it. Anyway, let's read the rest. Let's read on from here. So the investigation highlights how commercial AI services can lower the technical barrier to entry for offensive cyber capabilities. The threat actor in the campaign is not known to be associated with any advanced persistent threat group or with state-sponsored resources. They're likely a financially motivated individual or a small group who, through AI augmentation, achieved an operational scale that would have previously required a significantly larger and more skilled team. Really? You need a significantly larger and more skilled team to script up a password spray against a bunch of websites? Basically, it was essentially a bunch of websites. So, yet based on our analysis of public sources, they successfully compromised multiple organizations' Active Directory environments, extracted complete credential databases, and targeted backup infrastructures. A potential precursor to a ransomware deployment. Okay, so let's back up here a bit. You're saying they're these complete new cases, yet they're still achieving Active Directory compromise, dumping credential databases. I mean, what's going on here? I can think of a couple ways they're doing this, but I want to see what those are the questions I've got right now. Oh, so Orc says it's very common for nation states to intentionally appear unsophisticated. Yeah, no kidding. You don't want to go throwing your best tradecraft at something if you've got it in there. Let's see. All right, so going back to this, they said notably, when this actor encountered hardened environments or more sophisticated defense measures, they simply moved on to a softer target than persisting, underscoring that their advantage lies in AI augmented efficiency at scale, not in deeper technical skill. Really? Because this sounds like this doesn't sound like a large scale operation. It sounds like we're going after the low hanging fruit. That's exactly what this sounds like. Like I said, I know I'm bashing on all the claims here, and we're just in the intro, but we'll see what they can answer some of these questions when we get to the campaign overview. All right. So back to the article. As we expect this trend to continue in 2026, organizations should anticipate that AI, augmented threat actor, activity will continue to grow in volume from both skilled and unskilled adversaries. Strong defense fundamentals remain the most effective countermeasure. No crap. Patch management, perimeter defenses, credential hygiene, network segmentation, and robust detection for post-exploitation indicators. Yeah, so I love this. They're like, hey, by the way, AI is going to make everybody super elite hacksaws. But if you follow the most fundamental things that everybody in the security industry has been banging the drum on for the last infinity years, then you'll be good. Ha! I'm glad I started with this one. This one's getting me riled up. All right, let's look at the campaign overview. Through routine threat intelligence operations, ATI identified infrastructure hosting malicious tooling associated with the campaign. The threat actor had staged additional operational files on the same publicly accessible infrastructure, including AI-generated attack plans, victim configurations, and source code for custom tooling. I don't know too many unsophisticated attackers who are doing custom tooling. Maybe it's a verbiage issue, but there we go. This inadequate operational security provided comprehensive visibility into the threat actor's methodology and the specific ways they leveraged AI throughout the operation. Oh man. It's like an AI-powered assembly line for cybercrime, helping less skilled workers produce at scale. Well, that really is where AI is going. It's just going to scale up what one person can do. The threat actor compromised globally disparate FortiGate appliances, extracting full device configurations that yielded credentials, network topology information, and device configurations. They then used these stolen credentials to connect to the victim's internal networks and conduct post-exploitation activities, including Active Directory compromise, credential harvesting, and attempts to access backup infrastructure consistent with pre-ransomware operations. Oh yeah. I love how they're talking about, hey, by the way, AI is the end of the world, and look how many people these things popped. And at the same time, they're like, yeah, they kind of script kiddied this, and it was a password spray. Highlighting this message so hopefully will convince Jocko to sponsor the stream. That's right.
Reach Chris Young cheered 100 bits and says, "Go Blaze bits."
Thanks, man. By the way, you did overflow the bit buffer, it looks like, because I see one buffer overflow happened. I've been meaning to add a sound effect to that when it happens. Band, what's up, brother? AI is dangerous. It does things that you can easily... I can't read. AI is dangerous. It does things you can easily do too, but AI is so... Danger, Will Robinson. Yeah. It is, man. Heck, I'm using it pretty frequently now. Using it to do a lot of stuff. It really is the scale-up function to it. I'd say people that are going to suffer the most with not kind of adopting a lot of AI stuff, which there's not a lot. From what you guys have heard about, like on the stream, that's more than probably 95% of the population. They're using a lot of the AI stuff at surface level, like just talking to it through a chat interface. Probably 99% of the population has never even used Claude Code. I've adopted zero AI, honestly. Bro. I'm jealous. Because it really is like my new video game. It's like I finished doing Claude Code at work, so I can come home and do Claude Code at home. It's my game. What is this Chris sent? I can't wait to hear how this one renders.
Reach. Chris Young cheered 1,000 bits and says, L L L L L L L L L L L L L L.
All right, I'm gonna skip that because that's bad. I have to give it a try here eventually, and I'll have some ideas on things I want to work on easier. Dude, for the kind of work you're doing, it's really cool once you become familiar with the tool, because you can bring all of your subject matter expertise into that and use it to kind of guide it and then work with it. And then you start getting used to like doing the customizations for it, and then you can really make it work. It's cool. It's the bee's knees. All right, let's see how else they progressed this attack here. So for initial access, it was mass credential abuse. I'm all about abusing them creds. All right, the threat actor's initial access vector was credential-based access to FortiGate's management interfaces that were exposed to the internet. Bad. Do not do that. Do not expose your management interfaces out to the internet. Analysis of the actor's tooling supported semantic scanning for the management interface across ports 443, 8443, 10443, and 4443. Followed by an authentication attempt using commonly reused credentials. Oh my god, so neat. FortiGate configuration files represent high-value targets because they contain SSL VPN user credentials with recoverable passwords, admin creds, network topology and routing information, firewall policies, which gives you more internal architecture, and also IPsec VPN peer configurations. So meaning they compromise it, they can see what's on the other side of a VPN, and then like, oh cool, so there's another network that they control that we can go attack. The threat actor also developed AI-assisted Python scripts to parse, decrypt, and organize these stolen credentials. Ooh. Cool. They got AI doing spreadsheeting for them. Geographic distribution. So the campaign's targeting appears opportunistic rather than sector-specific, consistent with automated mass scanning for vulnerable appliances. However, certain patterns suggest organizational-level compromise where multiple FortiGate devices belonging to the same entity were accessed. Well, no crap, because they probably reused the same creds. Let's see. ATI observed clusters where contiguous IP blocks or shared non-standard management ports indicated managed service providers' deployment or large organizational networks. Concentrations of compromised devices were observed across a lot of Asia, Latin America, Caribbean, West Africa, basically everywhere. Everywhere. Anyone not using Cloud Code or the equivalent is way behind. I can do months work in a day. Dude, it is kind of crazy, orcs. And seeing that kind of scaling, it actually makes it very easy to start going into like doomer mode. And so I tell everybody, it's like, hey, don't go into doomer mode, because it's literally not possible for the entire economy to collapse and everything being AI automated, like AI robots and then AI all the things and replace all the workers. You can't have it because the economy literally would collapse. You don't have anybody to produce, to trade monetary value to then produce and then consume, right? It completely brings the consumer out of the economy. If there's no consumer, there is no economy. The only thing you can kind of do is go back to like neo-feudalism. This has to be fake news because all FortiGates come with a built-in RCE. We got vulnerability cases at work that I want to sift through and tell me which ones meet certain criteria. Oh, that'd be a cool idea. Yeah, that'd be an awesome use case, man. I'm not worried about scaling so much as automating tediousness. I agree with you there. And so one of the things I've actually been using it for, because I'm on a particular penetration test right now where it's on a completely new tech stack, is I had my AI assistant. I was like, hey, go gather all the information and make a research document about how this tech stack works so I can ask you questions. And then so it went through, took about 15 minutes. It gathered up all the information, collated it for me. And then I was able to say, okay, cool. Give me an overview of the operational workflow. Boom, 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 boom. Brings it down. I was like, okay. Then I was able to drill in and start looking at things. Then I can find the stuff in the application, like, hey, where does this map in the application from the documentation you gathered up? So it makes that cycle of having to learn on the fly and pick everything up a lot faster as it goes through. All right, let's get back to the article here real quick. Actually, to it, the ads are about to run here. Just a second. Let them run for real quick, and then I'll do the while the ads are running, I'll do the TTS spam from Chris.
Reach Chris Young cheered 10 bits and says, "Dear Jocko, sponsor this stream already."
I do need him. I'll have to send him that clip.
Reach Chris Young cheered 10 bits and says, "Maybe what the stream needs is more cheer number messages."
More cheer number messages. I mean, it's only limited by your creativity. For me, the cutting edge ceiling has been rising and I'm going up with it. That's kind of the way I look at it too, Orcs. Now, there's a weird kind of anxiety that comes with that too, because if your agents aren't doing stuff, you're like, you start feeling a little anxious. It started happening to me till I kind of backed up a bit. And I was like, wait a second, these guys work for me. I don't work for them. And so I was like, there's no reason for me to be anxious on when I can't sit down and like sit there and guide them. Or if I just don't have some huge task that they can go churn on and make a monolith. Sorry, man. Good job, Twitch.
Reach Chris Young cheered 25 bits and says, "Blaise Bits live stream intensity would be next level intensified if Jocko sponsored the live stream. Just saying.
Just
Speaking
saying.
for a friend. Oh, and that friend is also me. Go team."
Thanks, Chris. I know. So thankfully, I need to get in touch. So speaking about getting back into crushing it mode, I've not been able to exercise properly on a routine, basically since my sister passed away in September of 24. So I think finally, after all the family drama, all the injuries to my back, things are finally starting to come back together. I'm done with physical therapy. So I've got a doctor that I've been conversing with constantly. We're going to start working on getting me physically built back up so I can actually start racing again. So I'm not going to race in the same class I was doing. I think I'm going to work in the what's called the Blaster class. It's a particular type of four-wheeler called Yamaha Blaster. How do you handle proprietary information when using an AI in that way, or does your company have its own instances? So we do. If it is proprietary information, our internal guidelines are it strictly must be used on our internally hosted AI model. So that's very standard practice. If it is non-proprietary information, then we can use a public AI, in which case I'm using my own personal, Anthropic subscription. But actually, I'm working on something. I got something coming up. Maybe I can get this going tomorrow. But I'm working on a bunch of other ways to decouple everything from Anthropic. And I just did a test yesterday where I was running Kimi K25 with Claude Code, and there was some kind of a bug with it. And I think it was actually in the Light LLM proxy that was in the middle there. My second AI is your AI. My favorite AI is your AI.
Reach Chris Young cheered 25 bits and says, "Maybe what we need is merch that reminds us to switch into crush it mode."
Oh yeah, I think that'd be good. OpenCode's great for alternative models. I need to go test out OpenCode. I really do. It's not too terribly difficult to get Claude Code working on different models also. But I do still need to go give OpenCode a good and honest test. I briefly tinkered with the idea of trying OpenClaw and quickly just I don't like this. Something's weird about it. So did I try ZAI yet? I have not yet. No. What kind of GPU horsepower do you need to run an internal model? It depends on what you want to run. So there's no hard and fast guidelines as what's running on what was that? What's running on GPT 5.2 or Grok 4.20. Nice. Or what's running Claude Opus 4.6, right? But the main thing is, yeah, like Guy said, you generally need lots of VRAM. You got to have something where you can get the model into memory and store it. And the general estimate that from what I've kind of gleaned from a couple things is that you need something like, I want to say it was like a terabyte of VRAM. So not an insignificant amount to run that. And to put that into perspective, like the really big NVIDIA cards, I think top out at, I want to say 192 gigs. Let me double check that. Shut up, baby. I know it. That doesn't sound right. Oh, interesting. I guess technically the card with the most in it is the RTX Pro 6000 from NVIDIA, which has 96. I could have sworn they had some 128 gig models. I thought the H100 had more, but apparently it's got 94. Oh yeah, not sponsored by Jocko yet. Ah, there we go. Yeah, that's what I thought. The H200 has 141 gigs in it. But let's say, for example, you had to run that. You're talking you need 8 of those. Well, 7 of them. You need 7 of those to be able to run like those state-of-the-art cards. And the H200s are, how much is that? I want to say they're 35,000 a piece. I was close. It ranges between 30 and 40K. But if you want to rent one, you can usually rent one on a cloud hoster for little as $2 an hour. I'm going to have to learn Rust in the future, apparently. No Rust. Bad Rust. All right, let's get back to the article here, because I want to see what they were talking about for this, because I'm still not convinced that these guys are, I don't know, they're giving me conflicting information. They're saying, hey, they're doing this, but they're also saying, hey, they're script kiddies. I'm like, okay, the two of them can be similar, but I'm hoping they give some more hard and fast information. All right, so for their custom tooling, they said, following the VPN access to the victim network, the threat actor deploys a custom reconnaissance tool. So now they've got a custom reconnaissance tool, but also they're script kiddies. I was like, come on, man. And this had different versions written in both Go and Python. Analysis of the source code reveals clear indicators of AI-assisted development, redundant comments that merely restate function names, simplistic architecture with disproportionate investment in formatting over functionality, naive JSON parsing via string matching rather than proper deserialization. That is pretty bad. And compatibility shims for language built-ins with empty documentation stubs. So while functional for the threat actor specific use case, the tooling lacks robustness and fails under edge cases, which is characteristics typical of AI-generated code. Okay, cool. So there's still a level of understanding that has to happen here, right? Recon AI sense. Yeah. So there's still a little bit of understanding that has to happen here, right? These guys had to have at least some technical understanding to this. Because nobody just says, hey, I'm going to just go pop a bunch of FortiGates and be like super elite Haxor from Netrunner, right? They've got to have an understanding of what's in there and what they're getting. I don't think they just stumbled their way through each of this. I don't know. Maybe I could be wrong. They could tell me this later. All right. So on the article, it says, the tools automated the post-VPN reconnaissance workflow. It ingested the target networks from the VPN routing table, classified the networks by their size, ran service discovery using GoGo, which is an open source port scanner, automatically identified SMB hosts and domain controllers, and integrating a vulnerability scanner using Nuclei, Nuclei, an open source vulnerability scanner against discovered HTTP services. Okay. So they're not super elite, but also they're not the script kiddies these guys are making them out to be, because there is a certain level of technical knowledge that if you do not have, there's no AI in the world that's going to get you over that hump, right? So for post-exploitation, their methodology was once inside the victim's network, the threat actor followed a pretty standard approach leveraging bunch of well-known open source tools. For domain compromise, the threat actor's operational documentation details the intended use of Meterpreter. Okay, yeah, they're script kiddies. Yep, all my supposition is just out the window. Ugh. Freaking Meterpreter. They had a lot of intended use of Meterpreter, which is an open source post-exploitation kit, with the Mimikatz module to perform DC sync attacks against domain controllers. Now, that's key though, because you got to have some kind of domain admin permissions. Now, they probably could have got that from that FortiGate configuration. I'm not sure. I never configured FortiGate systems or Fortinets. I'm not familiar with what's all is inside those configurations. However, from other systems I have compromised, that's not a far stretch. Anyway, they said this allowed the attacker to extract NTLM password hashes from AD. Let's see. In confirmed compromises, the attacker obtained complete domain database or credential databases. In at least one case, the domain administrator account used a plaintext password that was either extracted from the FortiGate config, there it goes, through a password reuse, or was independently weak. For lateral movement, after doing a domain compromise, the threat actors expanded access through pass the hash and pass the ticket attacks against additional infrastructure, NTLM relay attacks using standard poisoning tools, and remote command execution on Windows hosts. Now, what's key here is, I'm gonna say this: if they're doing NTLM relays and they're using a C2 in here, those are not incredibly easy to do, and it's not difficult really. But this goes back to the level of understanding these attackers would have had to have if they're doing an NTLM relay over a C2 channel. It's a completely different story. Here, hold on. Let's take a look at it real quick. Here's how this has to break down whenever you do this. Let's see. Sorry for the flashbang. All right. So when you're doing a relay attack, here's what happens, right? So you've got an attacker computer here, right? So we have our attacker right here. We've got ourselves a victim, right? Meow. And then we've got some kind of target server that we're trying to connect to. Usually this will be over something like SMB, but there's other ways you can also do this. So what happens is the victim in some way is tricked into talking to the attacker. The attacker then forwards that over to the target, builds up a two-way connection here, a two-way connection here, and then just before the connection finalizes on the victim side, they kill this one, but let this one continue. Boom. Now what they've done is they've established a clean connection from the attacker to the target. Now, if you're in a single network right here, this is super easy. However, if these guys are doing this over a C2 channel, which sounds like they were, it works a little bit different, because you now all of a sudden you've got your C2 server sitting over here. You got your attacker sitting down here, right? You've got whatever victim that's running your C2 agent over here. And then now you've got your target server over here. But then also, more than likely, you've got victim number 2 here that you're going to try to trick into doing the authentication. So what happens? We've got two-way communication here between these guys. We're also going to have two-way communication between the victims and these. Chances are this is probably a flat network. But here's what happens. Let's say we send a coercion down to victim 2 and we get it to talk back to us. Well, great. This computer doesn't know anything about how to handle that. So you've got to set up what's called a reverse port forward. And that is to allow the traffic to come back to the C2, back to the attacker. And then you likely have to have some kind of a proxy connection going back. We'll do that in purple here. So then you've got to have like a SOX proxy or something, sending this back, and then sending it back to the attacker, and then sending it back down to V2 over here. All this is done so that they can also eventually get this connection going to the target and building here. The network infrastructure, I know people who have been working in security for a long time, and they still struggle with setting up this kind of a relay just because it's a lot of hops, it's a lot of moving parts. So if the attackers have this level of understanding, then who cares if they're using basic initial access methodologies? It was successful, and they're using AI to, as we were talking about earlier, automate the tedious crap. Yes, you could also have the DC in here, Gumby. You don't necessarily, the target probably is the DC over here. Usually that's the case you're trying to probably get to, but it could be to any other system in here. So for them to be doing NTLM relay attacks, let's see, where do they say it? Yeah, right here. NTLM relay attacks I mean, even if they're using standard tooling, going through and setting that up on the C2 system is not a trivial matter. It's a solved problem, but it's not trivial. Until I see some nation-state level attacks using some kind of automation on par with things like commercial pen testing automation, I'm just not super impressed. I'm not either, Ben. I'm right there with you. All right, now here's one of the other interesting parts. So they targeted backup infrastructures, and they specifically targeted Veeam backups and replication servers, deploying multiple tools for extracting more credentials, which this right here, a lot of script kiddies, they don't even know what Veeam is. So like I said, this is not an idiot attacker. This is just one who's using AI to automate the tedium. I don't blame them. I do the same thing. So when they're targeting these Veeam servers and the replications, they deployed multiple tools for credential extraction, which is great. I love to do that, including a bunch of PowerShell scripts, compiled decryption tools, and exploitation attempts leveraging known Veeam vulnerabilities. The backup servers represent high-value targets because they typically store elevated credentials for backup operations. Yeah, I can't tell you how many times I've compromised a backup server and pulled down like a full disk image of a domain controller, and it's just game over at that point. It did say they had limited exploitation success. The attacker's operational notes reference multiple CVEs across various targets. Now, here's the other thing. If they're taking operational notes, they're also not a script kiddie. As I'm not saying these are like nation state, but there's areas in there, right? There's areas of levels in there. Attackers have layers. Ogres have layers. Let's see. So back to the article. However, a critical finding for this analysis was that the threat actors largely failed when attempting to exploit anything beyond the most straightforward automated attack paths. Their own documentation records repeated failures. Targeted services were patched. Oh no. So they're script kiddies because the organization actually did patching. Yeah. Required ports were closed. Oh no, they're script kiddies because the network admin actually restricted access. Or vulnerabilities didn't apply to the target OS version. Yeah, I've fallen for that too. I love how there's just a dangling comma right there. Their final operational assessment for one confirmed victim acknowledged that the key infrastructure targets were well protected and no vulnerable exploitation vectors. There you go. All right, so then they go on to talk about AI as a force multiplier. Let's see, ATI analysis revealed that the actor uses at least 2 distinct commercial LLM providers throughout their operations. So AI-generated attack planning, let's see, this was a generated comprehensive attack methodology complete with step-by-step exploitation instructions, expected success rates, time estimates, and prioritized task trees. And the plans reference academic research on offensive AI agents, suggesting the actor follows emerging literature in AI-assisted penetration testing. Okay, if they're following that, like I said, this doesn't mean that they're an unsophisticated attacker. It means they're going through and they're doing this now. Think about this. This is probably the worst that this kind of stuff is going to look. It's only going to improve from here. So just because somebody is doing something with a different tool set and doesn't look like a polished master, doesn't mean that these guys are script kiddies as they alluded to in the beginning of the article. See, the AI produces technically accurate command sequences, but the actor struggles to adapt when conditions differ from the plan. They cannot compile custom exploits, debug failed exploitation attempts, or creatively pivot when the standard approach fails. Okay, so they're not elite, but they're not stupid also. Ooh, multi-model operational workflow. So ATI identified the actor using multiple AI services in complementary roles. One service as the primary tool developer, attack planner, and operational assistant. A second is used as a supplementary attack planner when the actor needs help pivoting within a specific command or compromised network. In one observed instance, the actor submitted the complete internal topology of the victim, the active victim, including IP addresses, host names, credentials, and services, and requested a step-by-step plan to compromise additional systems they could not access with their existing tooling. That does sound rather script kiddie, but like I said, there's layers. There's layers. Yeah, they couldn't compile custom exploits. What? If they're using any kind of coding agent, that should have been no problem, band. Dang it, I already finished my Jocko drink. Get the last dregs out of it. Let's see. What else did they do here? All right, so for about the tooling at their scale, they're talking about AI-generated tooling at scale. Beyond the reconnaissance framework, the actor's infrastructure also contained numerous scripts in multiple programming languages, bearing hallmarks of AI generation, including configuration parsers, credential extraction tools, VPN configuration automation, mass scanning orchestration, and result aggregation dashboards. That's pretty cool. I like that idea. The volume and variety of custom tooling would typically indicate well-resourced development teams. Instead, a single actor or a very small group generated this entire toolkit through AI-assisted development. Yep. Are we surprised? I'm not convinced the article itself wasn't written by AI. It's got a lot of hallmarks of AI slop. We've seen it before, Bobby. Also, what's up, dude? Happy Wednesday. Happy Wednesday to everyone. I hope you all are having a fantastical, wonderful, wondiferous, whimsical Wednesday. There you go. I got to come up with some more W adjectives. All right, let's see here. So threat actor assessment. Based on the comprehensive analysis, ATI assesses the threat actor as the following. Motivation. Suspected financially motivated based on widespread, indiscriminate targeting with low sophistication. What, they can't be highly sophisticated and still be motivated by money? Come on, man. Language, Russian speaking, based on extensive Russian language operational documentation. Oh, yeah, that's cool. I wish I could get a copy of the documents they got. Skill level, low to medium. Baseline technical capabilities significantly augmented by AI. The actor can run standard offensive tools and automate routine tasks, but struggles with exploit compilation, custom development, and creative problem solving during live operations. Now, I'll be real with you here. When it's talking about they couldn't customize or compile customized exploits, you know what? That's something even I don't do on a daily basis. I cannot remember the last time I had to customize or compile a raw exploit for something. I just don't need it very much in like the kind of work that I'm doing. I go through and I compromise systems using all the built-in functionality, complete living off the land, mega lols mode. That's usually what I'm doing 9 times out of 10. I'd say probably even 99 times out of 100. That's what I'm doing. So for them to be struggling with that, I've not seen that as like a really big hurdle. Now the killer here though is like, why couldn't if they're doing everything like AI augmented, why couldn't they have the AI help them get the compilation working right? I don't know. AI dependency. So extensive reliance across all operational phases. AI is used for tool development, attack planning, command generation, and operational reporting across multiple commercial LLM providers. The operational scale was broad, compromised devices across dozens of countries with evidence of sustained operations over an extended period. Post-exploitation depth, shallow. I don't care if it's shallow because you literally said they were taking over domains and popping backup servers. Repeated failures against hardened and non-standard targets, with a pattern of moving on rather than persisting when automated approaches fail. You know what? I do that too. If I'm running up against something and it's a weird case and I don't think it's going to bear fruit, I'm going to move on to a better target anyway. Now, this is funny though. Operational security, inadequate. Detailed operational plans, credentials, and victim data stored without encryption alongside tooling. I don't think a lot of attackers really give a damn. Now, probably their biggest OPSEC failure was whatever they left out on the internet that allowed ATI to go gather all this information. That's their biggest OPSEC failure. And it's every time these guys get caught, it's always an OPSEC failure. Just like whenever the network goes down, it's always DNS. Whenever these guys get caught, it's always an OPSEC failure. Yeah, OPSEC fails with a Z. Being augmented by AI means you suck. Now listen here. I take offense to that. I resemble that remark. Well, yeah, well, for the kind of work that you do, Band, yes, I'm not surprised you're constantly compiling custom exploits. You should resemble it. I do. I got the beard to prove it. Look at that. Look at that. Look at that me. It's not always DNS. It's sometimes it's the Wi-Fi card. Yeah, could be that too. All right, so what was Amazon's response to all this? ATI remains committed to helping protect customers and the broader internet ecosystem by actively investigating and disrupting threat actors. Upon discovering this campaign, ATI took the following actions. Shared actionable intelligence, including indicators of compromise with their relevant partners, collaborated with industry partners to broaden visibility into the campaign and support coordinated defense efforts for democracy. Through these efforts, Amazon helped reduce the threat actor's operational effectiveness and enabled organizations across multiple countries to take steps to disrupt the efficacy of the campaign. And then they've got some defending your environment ideas here, which basically boil down to make sure your FortiGate's not exposed to the internet, don't use crappy credentials, and make sure you've got something in place for monitoring your network once they get in. In other words, follow security in depth. It's too funny. Too funny. All right. Let's see here. Too good.
Reach Chris Young cheered 25 bits and says, question, when you executed that pen test research, did it provide accurate details about your infrastructure you were intending to understand better?
So you executed that pen test research. Did it provide accurate details about your infrastructure you were intending to understand better? Yeah, it did. Now, I wasn't asking it specific questions about the infrastructure. I was asking it questions about the understanding the tool setup whenever I was doing that. So I had it go through and ingest a whole buttload of open source documentation on the tech stack. So that way, as I found things, I would then tell it, it's like, hey, by the way, without giving any specific details. Yeah, one sec, Gummy. I would tell it, like, oh, hey, by the way, this portion of the tech stack is integrated over to this portion, and here's how it's integrated. That's it. So no client-specific information was ever popped like that. Now, speaking of finding vulnerabilities, Ben, this might be right up your alley. This is 100 plus kernel bugs in 30 days. High-scale driver vulnerability research with agent swarms. So the TLDR is, we used AI agents to reverse engineer Windows kernel drivers to find 0 days. It worked better than expected, which is bad. B-sods. B-sods everywhere. I love this note here. This blog was written by hand and edited with AI assistance. Actually, so typically whenever I'm writing something, I usually have writer's block real bad. So I will use the AI to kind of get ideas out, and then I will customize them for what I'm doing. Because starting a blog post is by far like the hardest thing. All right, so this article, let's go ahead and kick it off here. Frontier language models have already proven themselves for security audits of open source projects. AI-powered researchers found tens, maybe hundreds, of critical CVEs that human researchers have missed for years. Isle Croft, I hope I'm saying that correctly, and I have an even bigger concern. What about all those targets no one has ever looked at? This was literally terabytes of binaries running on millions of machines across the world no human researcher ever bothered to look at. Most likely no one ever will. We decided to put agent swarms to the test by building a simple harness to perform binary 0-day research at scale. Now, spoiler alert, they don't actually release the harness here. So just letting you know. So on the article, we targeted Windows kernel drivers, thousands of third-party sys files ship on every OEM machine, each one cryptographically signed by both its vendor and Microsoft with questionable code quality. Yeah, that's true. To date, most security research and mitigation efforts around Windows drivers focused on intentionally malicious rootkit-style drivers, binaries that expose unsafe APIs, or basically have deliberate backdoors in them. Microsoft's vulnerable driver block list and the community projects like LOL drivers catalog these known bad drivers and prevent them from being loaded. But this misses an entire class of vulnerabilities, unintentional memory corruption bugs inside otherwise legit drivers. These aren't backdoors, but rather a garden variety bug written by legitimate vendors. No block list catches them because no one has ever audited their code, and preventing them from loading will prevent you from using your GPU, keyboard, or your webcam, any other hardware device. So to do this in a cost-effective manner, we built an autonomous platform that scrapes drivers from all over the internet, catalogs and labels them, decompiles them, and uses agent swarms to identify memory corruption vulnerabilities with minimal token use and maximum plain old Python. By using small language models for much of the analysis, the entire project only cost us about $600 US, roughly $3 per analyzed target. Cool. From the data set of over 1,873 binaries, we found 521 potential vulnerabilities across 158 unique driver binaries from dozens of vendors. Of those, we manually confirmed and reported 15 to the vendors, including Lenovo, Fujitsu, IBM, Intel, AMD, Silicom, NVIDIA, and Dell. And they were unsurprisingly unresponsive. They don't like it when you go digging into their drivers, I'm just saying. Yeah, no blocklist catches this. Well, duh, you're talking about an O-Day. I know, right? Let's see. So despite most confirming the vulnerabilities exist with screenshots or video proof, to date, only one vulnerability was patched. And we'd like to thank Fujitsu's PSIRT for their handling of the submission. Good job on you, Fujitsu. Let's see. It's most important to note that the PSIRTs saw it as a responsibility to alert Microsoft of these vulnerable drivers and add them to the block list or revoke their certificate. After 90 days of responsibly waiting for them to fix submissions, we are publishing a full list of analyzed driver hashes so defenders can check whether affected binaries are present in their environment. If you're a vendor, customer, or security professional interested in more details, you're welcome to reach out to us. I might go ask him. Ask him about that. Even though driver exploitation is not my forte. All right, hold on. The ads are about to run, and then we'll cover the methodology here in just a sec. Let's see. Let the ads run for just a second. Let's see what Chris has been spamming up.
Reach Chris Young cheered 25 bits and says, maybe more drawing board field trips would make the cybersecurity industry more productive.
I highly agree. Yes. I miss having the iPad. I cannot make the iPad work with this setup, unfortunately. So, or at least I haven't found a way to make it work, because I loved being able to draw with the pencil.
Reach Chris Young cheered 100 bits and says, the bigger bitty donations are reserved for the enthusiastic messages to support the live stream.
Thanks, man. Yeah, so up here, this guy right here, the buffer, once it hits 500 bits, it overflows. And then it reinitializes the buffer. So that's kind of a fun thing. I just thought I vibe coded that. I literally said, hey, Claude Code, here's all the documentation on StreamerBot, which is what's running the stream, and here's what I want to build. How should we do it? And it's like, cool, here it is. And it built this god-awful ugly thing. So I was like, okay, no, let's build a theme for like a retro cyberpunk setup, and then we could do this. No paying more will make the cyber community more effective. Hold on. I'm trying to make sure I can read the name correctly. Cecilin. Clarify that, because yeah, I think one of the big problems in security is, like, and so many other things, they're just like, hey, can we just throw more budget at it and fix it? It's like, no, you got to get the fundamentals down. Get your blocking, tackling, and passing down. Bam, you're good.
Reach Chris Young cheered 25 bits and says, Rust isn't a language. It's what produces roots on cars abandoned in the streets of Detroit.
Right? Cecilin, hey, no problem, man. Dude, I enjoy doing the live streams. I was really sad that I really wanted to do Sunday night's stream. I was just absolutely beat down from the weekend. I was not firing on, I was probably firing on one cylinder. Like, I had okay, gotcha, man. I like all the cylinders that I got up here, which ain't a lot. I had just one firing, and it was just puttering, just. I was rough on Sunday. Let's see here. All right, cool. The ads are done. Let's go over what the methodology was for them to find all these kernel drivers. So our flow runs in a 5-stage pipeline. First one was to scrape. We covered both the Microsoft Update Catalog, OEM sites, and public driver repos. Overall, we collected 1,654 different drivers across 1,873 unique binary versions. So they had multiple versions of some of the drivers. For pre-processing, they did cab extraction, PE metadata analysis, and catalog signature parsing. So this stage computed hashes, identified the driver's entry points, and ranked targets by their attack surface indicators, by their IO control dispatch complexity, number of device objects they presented, presence of it. They had method neither handlers, which I'm not even sure what that is. Like I said, my driver knowledge is weak. And to focus the analysis, we filtered out drivers requiring complex setups. So mostly non-USB or PCI devices in older versions. Sorry, Windows XP users. Yeah. All right, Chris, have a good night, man. Take care, brother. Let's see. And then, so step 3, for their analysis, this was the core loop. So for each target, we launched an audit harness. Today, we'd probably just use Claude Code or OpenClaw with custom skills. Okay, so they did say that they had been sitting on this for a while. So this article came out. Where is it? Let's see. Hey, Gumby. So this article just came out on the 23rd, but they've been sitting on this for like 90 days, right? More than 90 days. So they must have done this, let's see, this is February. They must have been doing this around November, December timeframe. Let's see. So we had a council of language model agents going back to this. Oh, let me reread this part for the analysis. So the core loop for each target was we launched an audit harness. A council of language model agents then iteratively audited the binary. So they did they had a decompilation agent, which renamed unnamed functions, deduced functionalities, recovered dynamic calls, uses contextual interfaces so the auditors could follow the logic. Then they had an attack surface agent, which identified functions worth auditing based on the decompiled code. And then they had a code audit agent, which inspects each target function for memory corruption bugs, walking the recovered call graph to uncover whatever that data flow was. So findings were written into a structured JSON with a bug type, severity, confidence, and impact assessment, and the decompiled code path. And they used a mixture of models via OpenRouter. Yeah, I like OpenRouter. Optimizing for vulnerabilities per token rather than per model accuracy. On average, each target costs roughly $3 in API calls. Now, that's actually quite a bit because the amount of data that they're churning through with this, and they're using smaller language models that don't cost a lot, like per millions of tokens. And they're talking like, hey, we use like $3 for here. They probably used anywhere in the neighborhood of 1 to 3 million tokens per driver. So, I mean, a good chunk. Smells like team spirit. All right, number 4, virtualization. This became the bottleneck once we had a queue of 100 plus findings. So we created a custom VM-based harness for loading drivers into kernel debugged Windows machines controlled by the agents. Some drivers required custom USB and PCI devices we didn't have on hand, and we customized QEMU to expose virtual devices and used language models to virtualize enough of the initial handshake for the driver to load and expose their IO control interfaces. Cool. Yeah, that sounds like that would be a pain in the butt right there. Building the actual test system. Let's see, for validation, using our harnesses, we can iteratively create proof of concept Python codes per finding, effectively performing guided fuzzing until the machine crashes. The B-side crash dump is then analyzed to confirm the vulnerability indeed triggered correctly. And we found many hallucinated reports where the fuzzer successfully caused a crash without actually exploiting the finding, causing a sneaky false positive we had to debug manually. Interesting. Let me go over that again. So we found many hallucinated reports where the fuzzer successfully caused a crash without actually exploiting the finding. That's funny. So it's like, oh, well, it crashed. It's got to be the finding, right? But they did it like a different path. All right, so the last step they did was for the reporting. So we manually validated the automated reports running our proof of concept script on a real Windows 11 machine, ensuring the vulnerability description is comprehensive and factually correct. We then submitted that to the PSIRT ourselves. Note that we did not actually weaponize most vulnerabilities into full local privilege escalation exploits, but instead gauge the likelihood of being exploited in a real-world scenario based on their experience. And this is what I was talking about. They're gauging this based on their hard-won, human-built experience as they're going through this. And that's where you can actually do a lot with this. So you can use these systems as like a learning aid, But if you try to like step out of your wheelhouse into something, you'll never know when the model is lying to you or leading you astray. So like, for example, up here, if they didn't understand like how to actually fix this virtualization issue where they needed to have these virtual machines connected to QEMU to actually get that running, that would be a big issue with it. I love the gigantic, legally distinct Cookie Monster. All right, so here's what we're looking at for this setup. After they ran through this entire pipeline, so of those 1,654 drivers in the data set, we selected 202 high-risk drivers for full analysis based on the pre-processing heuristics. The remaining drivers are queued for future passes. The results are, they collected a total of 1,873 binaries, which some of those were multiple versions. In total, there were 1,654 unique drivers. They analyzed 202 of them, had 521 findings. 158 of those binaries had unique findings. Or sorry, that was the unique binaries with the findings. They manually confirmed 15 of them, because that's a lot of work. And they had 8 vendors to notify in total. Hey, Paperclip, what's up, man? So all in all, total cost per bug was about $4. Not bad. Now here, this is interesting. What was the bug type distribution? Arbitrary read, that's a big one. Especially if you consider these are kernel mode drivers. They're running with the utmost unrestricted access to the system. So if you have an arbitrary read, any sensitive file on that system is yours to take. Heap overflow, that's just raw command execution, assuming that you can make it work and you can get the attack chain actually built out there. Integer overflows, stack overflows, arbitrary writes. Arbitrary writes is another good one in there, because then you have write permissions to just about anything you want to on the system. Use after freeze, and then type confusions in here. Nice. Nice. I wish I had stuck more with binary exploitation when I was doing it back around 2010. But I stopped earlier because I was doing other stuff. I wish I had kept on with it. Like playing the piano. I wish I had kept on with playing the piano when I was younger. Let's see. So back to the article. Arbitrary memory access bugs for read and write accounted for 54% of all the findings, which was unsurprising given that I/O control handlers routinely copy data between user and kernel buffers with no bounds checking. Most of those stem from either heap buffer mishandling or from a fully deserialization logic. Of the criticalities they found, 149 were critical, 220 were high, 148 were classified as medium, and 3 lows in there. Let's see. So roughly 70% of the findings were rated as high or critical, and 78% of the findings having a pretty high confidence in it. That's pretty good. Especially considering they weren't using any state-of-the-art models for this. They were just doing it with small language models. I think they were just letting the language model write this themselves, Band. They had maybe, I don't know if they had any kind of criteria. Yeah, I don't know what their grading criteria is because they did not release the harness that they used for this. All right, now this is another interesting part, the false positive rate. So after manual analysis, we estimated the false positive rate was approximately 60%. Oof, that's bad. And this was 60% of the critical and high confidence findings. Most of the real code patterns where the bug exists, but exploitation was impractical. For e.g., given an out-of-bounds read that can only leak padding bytes, or a write that requires special system conditions. Adjusting for this, we estimated of over 100 of the 521 findings represented genuinely exploitable user-to-kernel local privilege escalation on a current Windows 11 system. I find it funny they mentioned that this is a Windows 11. Okay, I was going to say x64 because I don't think they even make Windows for 32-bit, but they do make Windows 11 for ARM now. So, yeah, you could say anything is critical banned in there. But I mean, one of the cool things is, though, if you have some kind of scoring metric and grading criteria and you give that to the model, then what they've done is they've effectively made a pipeline for them to go through and triage all this stuff ahead of time. Let's see. So for the impact, to reduce the hallucination rate, the agent was asked to propose maximum impact of a vulnerability exploitation for each reported finding, and the most common impact categorized across the findings. So the main one was denial of service, info disclosures, privilege escalation, and code execution. Privilege escalation was arbitrary kernel read writes. Yeah, that's a good one. Let's see. Code execution would likely coming from those heap overflows or use after frees, which would be exploitable and get you code execution if you could do pool shaping in the kernel, or it's in memory there. I would say probably if you're saying it's a critical LPE, it's because it's going to take you from low system user to like a standard Windows user in medium integrity all the way up to a system account. Right? Technically, this is technically above system level permissions. It gets weird when you start talking about that, though. Let's see. That's most every driver vuln. Well, that's why driver vulns are so bad, and why bring your own vulnerable driver was such a big deal. Whenever everybody's like, "Hey, let's do this." All right. So, what about this notable vulnerability patterns? AMD's crashed. So, for an example, AMD's crashed events driver exposed a world routable device that supports sending I/O controls with proprietary operational codes, and those operations on the device access internal transport queue descriptors without any proper size validation, which allowed heap corruption. So, with pool grooming, this is a path to arbitrary kernel data access or even kernel code execution. Without it, it's a reliable BSOD for any user account. So it'd be a denial of service. That's blue screen of death for anybody who's wondering what the heck's a BSOD. The driver ships on a Windows AMD system including the AWS EC2 AMIs for Windows. That's funny. All right, so the same common binary exploitation pattern accounted for the majority of the findings. It was unclear whether it's because driver dev teams skip modern security tooling entirely or because of the highly problematic nature of both WTK and KMDF makes the pre-LLM static analysis feasible. Hey, Ben, do you know what they're talking about here when they say WDK and KMDF? Those are two acronyms I'm not familiar with. Oh, those are driver development frameworks. Okay, that would explain why I know nothing about them. Got it. Let's see. So let's look at what they were talking about for the reported vulnerabilities. So we manually confirmed and reported 15 vulns to 8 vendors, all with CVSS ratings of 7 or higher, and all have been under disclosure for over 90 days. The average CVSS across the reported findings was an 8.2. And most bugs are exploitable from a standard unprivileged user account. Most require nothing more than opening the device handle and sending a sequence of device I/O control calls. Windows drivers, the Windows drivers are Microsoft signed, meaning they can be loaded by anyone on a Windows machine via a bring your own vulnerable driver attack, even if the associated product was never installed, requiring admin permissions, things like that. Because those signed Windows drivers have special permissions on the operating system. Oh, hey, Rabbit and Miso, thank you for coming online. The alerts are still busted. I apologize. I'm working on that right now. But thank you guys so much. I appreciate it. Very, very much appreciate it. All right, let's see. Was there anything else in here? IOCs for the hashes. That's why the article's so long. Look at that. Look at that list. Brr. IOC list goes brr. That's still really cool, though. I love that. This is actually one that's really important to know. So they said they reported 15 of these to 8 different vendors, and only Fujitsu actually responded. That's pretty bad. All right, let's see here. Let me see what else we've got up in LayQ here. So that was this one. We covered that. Oh, this is another good one. And this is horrible because it was such a piddly amount of money. I am not a robot. That button doesn't stop anybody now. I just want you to know that. The robots know how to click buttons. I'll tell you guys, give me 1 sec. Let me go grab my water, and I'll be right back. All right, I'm back. I am back. Guess who's back? Back again. Blaise is back. Tell a friend. All right. Gumby is the supreme overload, and I was not pooping Gumby. All right, one second. Let me check up on the chat. You guys, and I don't know why. Okay, I do know why. I remember why I put in the poop counter. It's because it was a joke from my buddy, and then you guys just freaking ran with it. I thought nobody would even use it. I thought he was the only one who was going to do it. And then all of a sudden, you guys are like, anytime I can be on camera. Doesn't matter if I'm on camera or off camera. You're just like, poop command. What are we up to anyway? 186. That is 185 lies. Let's see. Hold on, I'm catch up on the chat real quick here. So I'm getting into cybersecurity, so I need to start following people who are talking about it. You're the first one. Oh, dude, welcome in, man. When I put Q&A, Miso, in the stream title, I 100% meet it. So you got questions, I've got answers. And if I cannot dazzle you with my brilliance, I will baffle you with my bullshit. Let's see here. All right, what's next on the docket? Oh, let me get the link for everybody. This is going to be a short one because this is from the Justice Department. Bank insider pleads guilty to facilitating fraud schemes from inside two financial institutions. Let's see. So this is from the Newark team. I don't know what they're talking about here, but anyway. So Edward Lowe, aka Mang Huan Lowe, or aka Eddie Lowe, a former New York-based employee at TD Bank NA, and another financial institution, which I don't know if they name it or not, pleaded guilty today to accepting bribes to provide confidential customer information of TD Bank customers and to falsifying bank records to open bank accounts at another financial institution, which helped co-conspirators commit more than $500,000 of fraud. Lowe, yeah, I bet he's feeling real low right now. Lowe, age 31, pleaded guilty today before the Honorable Esther Salas in Newark on two counts of on a two-count information charging. On a two-count information charging. I don't know what that statement's saying. Anyway, 2 counts of conspiracy to commit wire fraud affecting a financial institution and making false bank entries or reports. He's scheduled to be sentenced on July 14th. This is February 17th. If you're pleading guilty, why the hell is sentencing going to take, what is that, 5 months? What the hell, man? If he pleads guilty, just sentence him right there. Anyway. So they said the defendant chose to sell his access to the banking system from the inside by accepting bribes at two separate financial institutions. He betrayed the trust placed in him and enabled outside fraudsters to exploit customer accounts and falsify bank records for personal gain. The U.S. Attorney's Office will continue to root out corruption with our financial institutions and hold accountable those, whether insiders or outsiders, who undermine the integrity of our banking system. Yeah, won't want anything to happen to them. According to court filings, the statement made in the court on January 2021 through May of 2021, Lowe, of Flushing, New York, Flushing. My mind's not in the toilet, yours is. Anyway, so Mr. Lowe here accepted bribes and leveraged his position to obtain confidential TD Bank customer information. He then passed the information to outside co-conspirators who used it to take over accounts and steal money from the customers. Lowe also processed some of the illicit transactions for the co-conspirators. In total, Lowe received at least $26,700 in bribes and facilitated $484,000 in fraud. So that's where I'm like, bro, you just threw yourself down the rabbit hole with no soft landing. Really, not even a rabbit hole, just a pit for 26 grand. Bro. That's weak sauce. That's what I was talking about. Like, these insiders, I'm like, now, this wasn't some dude in like a call center in India, right? Hey, Bob, what's up, man? And like, if this was 26 grand to somebody who's making, you know, maybe like 1,000 lakh a day, working out of a center in India, that's a huge amount of money. This is nothing if you're in New York. This is nothing. You couldn't even get a new car, bro. All right. So fast forwarding next from the notice here, from May of 22 to August of 22, Lowe was an employee at another financial institution. In exchange for a bribe, Lowe falsified bank records to help a co-conspirator open an account in the name of a shell company. The co-conspirator then used that account to commit another $47,000 of fraud. The charge of conspiring to commit wire fraud affecting a financial institution carries a maximum penalty of 30 years. So bro's looking at double his lifetime because he's 31 right now. And a fine of up to $1 million. Or twice the amount involved with the offense of the loss, or loss by victims of the offense, whichever is greater. Phew, that's funny. The charge of making a false bank entry carries a maximum penalty of another 30 years. So I doubt they're going to throw the maximum book at him because they just don't for white-collar criminals. But at the same time, that was the whole reason why I thought this was interesting. Is one, you can do everything right and still lose the game sometimes, right? You can protect your account, you can do all this stuff. And a malicious insider, that's why teams have insider threat detection teams, can go through and just really mess it up. But the main thing that surprised me was this part right here. And this is the whole reason why I wanted to read this article, is that they paid him a paltry 26 grand for doing 500 grand worth of fraud. Bruh. That was a fail, bro. You were underselling yourself by a lot. All right, what do we got? Let's see. I'll save that one for later. Oh, actually, here we go. This is another good one. Unfortunately, this was the only one that I could actually find that had this. And fucking Bloomberg. Can we just get rid of these now? Because the AIs can solve these. Yeah. I'm a human. Apparently, I'm not a human. I am a clanker. Did you see that some people wanted to classify clanker as a racial slur? Yeah. Or, yeah, gankers from the WoW days. Man, I loved WoW. WoW was the second MMO I played. The first one was Star Wars Galaxies, and I really liked that one. Cool.
Reach Chris Young cheered 25 bits and says, "Thank you for Blaise Bits and Live."
You're welcome, Chris. Oh, I'm going to run through these while this is processing.
Reach Chris Young cheered 105 bits and says, "I'm nowhere close to the 500 bits buffer."
Can we do this on archive? Will this one do it? There has to be an archive of this somewhere. Here we go. Someone got it. Good. I wonder if this will actually work for working through archive. I've never actually seen this before. These people speak in monotone gray voices that have shiny gray skin. It wouldn't surprise me. What have I done? I'm just trying to get to the article. RIP. Hold on. I do know a way to do this. Hang on one second. me see if I can do something here. So, if you didn't know this, if you click on a link and the refer is coming from Twitter, most of the time it will actually let you do that. Let's see if this will work. I don't want to do that. Claim this offer. No. Oh my God. Bloomberg, this is why nobody likes you. Let me try it one more time. Let's see if somebody surely has archived this yet.
RNO Gumby cheered 5 bits and says, "It a buffer overflow."
Yeah, buffer overflow.
RNO Gumby cheered 5 bits and says, "Did you have a good poop?"
I wasn't pooping. Hold on, let me see if I can find another copy of this real quick. Because Bloomberg can just eat a fat one. All right, let's see. Hold on, what if I come to it from Bloomberg here? I think probably from whatever tracking cookies they've got is going to eat it. Yeah, that one's not going to work. Times India, let me see. All right, I guess we're just going to have to go with Claims Journal here. Whatever this is. Let's read through this real quick. So this is coming from Reuters. This is hackers used Anthropic's Claude to steal sensitive Mexican data. So a hacker exploited Anthropic's PBCs. Anthropic PBCs? Whatever. I mean, maybe that's the actual corporate name. But anyway, hackers exploited Anthropic's artificial intelligence chatbot to carry out a series of attacks against Mexican government agencies, resulting in the theft of a huge trove of sensitive tax and voter information, according to security researchers. The unknown Claude user wrote Spanish-language prompts for the chatbot to act as an elite hacker, finding vulnerabilities in government networks, writing computer scripts to exploit them, and determining ways to automate data theft. Israeli cybersecurity firm startup Gambit Security said in their research published on Wednesday. Hold on, can we go find these guys? No, that's not the right one. Go back. Do these guys, they've got to have a blog or something. So I wanted to see if I can find the original source article. I could not find it earlier when I was looking for it. So these guys published it, but it doesn't say where they published it to. Oh, PBC is a public benefit corporation. Gotcha.
E-Oiler cheered 5 bits and says, "Did you disable my entrance music?"
I did. So what I did, Euler, is I put in a TTS queue, so now the messages don't just flood constantly. Plus, as much as I really liked the little bit transmit sound, it's so long. So I had to get it under control a little bit. Gambit Security reads like a 70s cop show. I wish I could find the original article. Anyway. Shut up, baby. I know it. Anyway, let's go back to... We'll finish off on whatever Reuters here put out. So they said... So the activity started in December and continued roughly for a month. In all, 150 gigs of Mexican government data was stolen, including documents related to 195 million taxpayer records and voter records, employee credentials, and civil registry files, according to that research. AI has become a key enabler in digital crime, with hackers using tools to augment their efforts. Last week, researchers at Amazon.com said a small group of hackers broke into more than 600 firewall devices. We just talked about that. Gambit hasn't attributed the attack to a specific group, though researchers said they don't believe that they're tied to any foreign government. The hacker breached Mexico's Federal Tax Authority and National Election Institute. And the state governments in Mexico, Jalisco, Michoacán, and Tamaulipas as well as Mexico City's civil registry and Montenero's water utilities. Damn, they kind of hit all of it, didn't they? Claude initially warned the unknown user of malicious intent during the conversation about the Mexican government, but eventually complied with the attacker's request and executed thousands of commands on government computer networks. Hit. Anthropic investigated Gambic's claims, disrupted the activity, and banned the accounts involved. The company feeds examples of malicious activity back into Claude to learn from it, and one of its latest AI models, Opus 4.6, includes probes that can disrupt misuse, disrupt misuse according to their representatives. In this instance, the hacker was able to continuously probe Claude until it was able to jailbreak it. I think they said, it's not in this article, but from what I was reading somewhere else, I think he jailbroke it actually by talking to it in Spanish. Like the guardrails didn't work in Spanish for some reason. Actually, here was another interesting part about this. And I would go through and read the article if I could find the original source article, but this was interesting. So when Claude encountered problems or required additional information, the hacker actually turned to ChatGPT to provide the additional insights. And that included how to move laterally through the computer network, determine which credentials were needed. So this guy's a script kiddie. This is more script kiddie-ish. Let's see. Gambit was founded by Gromorikov and two other veterans of Unit 8200, which you didn't know about that. That's basically like the Israeli NSA. That's what they are. That's interesting. All right, I'm going to bail on this because I can't find the original source article and I can't find the original research that they published, which pisses me off. All right, actually, hold on. Here's another very cool one from Truffle. So if you ever heard of Truffle Hog, which was a big player as part of, what was it? The Shai Hulud stuff. That was a good one. Here, Gumby, I'll drop this one in here. What I read is Anthropic aided and abetted for those with low ability bases. Yeah, right? Yeah, you know what's funny is actually Anthropic recently, I think they're backing off on a lot of their stances of like how they want their AI to be used because they're like afraid that they're going to be left in the dust because all the other guys aren't playing by the same set of like, I don't know, let's call it like ethical boundaries. Yeah. All right, so this one is from the guys that put out Truffle Security. And here's the dig. Google API keys weren't secrets, but then Gemini changed the rules. Oh, good old Gemini. So the TLDR here is Google spent over a decade telling developers that Google API keys, like those used in Maps and Firebase, aren't secrets. And that's no longer true. Gemini accepts the same keys to access your private data, and we scanned millions of websites and found nearly 3,000 Google API keys originally deployed for public services like Maps that now authenticate to Gemini even though they were never intended to. And with a valid key, an attacker can access uploaded files, cache data, and charge LLM usage to your account. Even Google themselves had old public API keys, which they thought were non-sensitive, that we then use to access Google's internal Gemini. RIP. Please don't notice me. Don't notice the API key here. All right, so what was the core problem? Google Cloud uses a single API key format for two fundamentally different purposes, public identification and sensitive authentication. So for years, Google has explicitly told developers that API keys are safe to embed in client-side code. No. Don't do that. Firebase's own security checklist states that API keys are not secrets. Ha! And Firebase has never been compromised. Not once. Nope, never. Never. Not once. Ever, ever, ever. So for years, Google had explicitly told developers... Oh, we already talked about that. No, these are distinctly different services from service account JSON keys used to power GCP. So API keys for Firebase services are not secret. Yeah, but if you don't permission them correctly, you're kind of SOL. Google Maps JavaScript documentation instructs developers to paste their key directly into their HTML. No. And this makes sense. These keys were designed to project, or were designed as project identifiers for billing, and they can further restrict with bypasses controls like HTTP refer allowing. They weren't designed as an authentication credential. Then Gemini arrived. So we enabled the Gemini API on a Google Cloud project. Existing API keys in that project, including the ones sitting in your public JavaScript, can silently gain access to sensitive Gemini endpoints. No warning or confirmation and no email notification. And this creates two distinct problems. Retroactive privilege expansion. That's a new term and I love it. So you create a Maps key 3 years ago and embed it in your website source code, exactly as Google instructed. Last month, a developer on your team enabled the Gemini API for an internal prototype. Your public map key is now a Gemini credential. Anyone who scrapes it can access your uploaded files, cached content, and rack up your AI bill. And nobody told you. Also, insecure defaults. So when you create a new API key in Google Cloud, it defaults to unrestricted, meaning it's immediately valid for every enabled API in the project, including Gemini. And the UI shows a warning about unauthorized use, but the architecture defaults to wide open. Bad defaults. And so the result here is thousands of API keys that were deployed as benign billing tokens and are now live Gemini credentials sitting in the public interest, or sitting on the public internet. And what makes the privilege escalation rather than a misconfiguration is a sequence of events. So a developer can create an API key and embed it in their website for something like Maps. The Gemini API gets enabled on the same project, and the developer is never warned that the key's privileges changed underneath. Rip. And so while users can restrict Google API keys, the vulnerability lies to the insecure default posture and incorrect privilege assignments. I love how they cited the Common Web enumerations here, the CWEs. So there's an implicit trust upgrade. Google retroactively applied sensitive privileges to keys, to existing keys that are already rightfully deployed in a public environment. And lack of key separation. Secure API design requires distinct keys for each environment. Publishable versus secret keys. And by relying on a single key for both, the system invites compromise and confusion. Much confusion. They also had a failure of safe default. So the default state of a generated key via the GCP API panel permits access to sensitive Gemini APIs, assuming it's enabled. A user creating a key for a map widget is unknowingly generating a credential capable of administrative action. That's so bad. That's bad. Hey, Scrappy, thanks for coming online, man. I hope I didn't miss anybody in there. Yeah, I got to get the audio alerts back up and running now. Let's see here. So what could an attacker do? So the attack is trivial. An attacker visits your website, visits the page source, copies down your API key. Oop, that's it. And instead of a 403 message when they go to the generative language API, they're met with a 200. And they can access private files. So the files and cached contents endpoint can contain uploaded documents, datasets, context enrichments, anything the project owner stored through the Gemini API is accessible. And they can also run up your bill. So since the Gemini API isn't free, depending on the model and context window, a threat actor maxing out API calls could generate thousands of dollars in charges per day on a single victim account. Also exhausting your quota, so this could shut down your legitimate Gemini service entirely. And the attacker never touches your infrastructure, they just scrape the key from your public website. So to understand the scale of the issue, we scanned the November 2025 Common Crawl dataset, which is a massive 700 terabytes. This is an archive of publicly scraped web pages containing HTML, JavaScript, and CSS from across the internet. We identified 2,863 live Google API keys vulnerable to the privilege escalation vector. That's a lot. This is the time for like mass exploitation, isn't it? And these keys aren't just hobbyist projects. The victims included major financial institutions, security companies, global recruiting firms, and notably Google itself. Ooh, we'll talk about eating your own dog food. If the vendor's own engineering teams can't avoid this trap, expecting every developer to navigate it correctly is unrealistic. And then now they've got a proof of concept using Google's own key here. Nice. So we provided Google with concrete examples from their own infrastructure to demonstrate the issue. One of the keys we tested was embedded in a page source of a Google product's publicly facing website. And by checking the Internet Archive, we confirmed the key has been publicly deployed since around February of 2023, well before Gemini's API even existed. There was no client-side logic in the page attempting to access any Gen AI endpoints. It was used solely for a public project identifier, which is standard for Google services. And we tested the key by hitting Gemini's API models endpoint, which just lists the language models that are listed out there. and got a 200 response, basically listing all the available models. Oh, that's bad. So the disclosure timeline was around November 21st. They submitted the report to Google's vulnerability disclosure program, VDP. And let's see. They initially said, "Oh, that's intended behavior." Of course they did. You know why they said that? Because it was freaking Thanksgiving. They're like, "I'm not dealing with this shit right before Thanksgiving." So then on December 1st, after they provided an example from Google's own infrastructure, the issue was gained traction internally. Google reclassified the report from a customer issue to a bug, upgrading the severity in the customer product team, and they requested a full list of the 2,863 exposed keys. They provided to it. Google had a remediation plan, classified the vulnerability as single service privilege escalation, which is tier 1. Boop. Google confirmed the team was still working on a root cause fix, and here on February 19th, they hit the 90-day disclosure window. So, if they're still working on do they have like any kind of mitigating fix in place? That's hilarious. Yeah, free AI tokens for life. Let's see. So credit where it's due. Transparently, the initial triage was frustrating because the report was dismissed as intended behavior, but after providing a concrete evidence from Google's own infrastructure, the GCP VDP team did actually take the issue seriously. They expanded their leaked credential detection pipeline to cover the keys we reported, thereby proactively protecting real Google customers from the threat actors exploiting Gemini keys. Okay, so that's good. They did actually take some proactive approach to it. They also committed to fixing the root cause, though we haven't seen concrete outcome from that yet. Oh, that's funny. Let's see. So building software at Google's scale is extraordinarily difficult, and the Gemini API inherited a key management architecture built for a different era. Google recognized the problem we reported and took meaningful steps. The open questions are whether Google will inform customers of the security risk associated with their existing keys, or whether Gemini will eventually adopt a different authentication architecture. I think that's probably the way they're going to go with it. Either that or just like maybe actually put some RBAC in place. Maybe got RBAC. Let's see. So Google did publicly document the roadmap. So there's scoped defaults. New keys created through the AI Studio will default to Gemini only access, preventing this kind of unintended behavior. Leaked keys were blocked. So the default to blocking API keys and discovered leaks used within the Gemini API. And they did do a proactive notification. So they plan to communicate proactively when they identified leaked keys to the clients, basically. So what should you do right now? Check your GCP project for those. If the generative language AI is enabled, audit all of your API keys. Verify none of the keys are public. Bonus, scan with TruffleHog. Got to get that TruffleHog bonus in there. You can also scan with TruffleHog to scan your own CI/CD pipelines and web assets for leaked Google API keys. Love it. I like TruffleHog. It's awesome. Hey, Blind, thanks for coming online, man. Let's see. So they closed down 2,500 website API access without warning and sent out a ton of emails saying your API has been spotted in the wild and disabled. Doing the thing we told you not to do, right? I think they just have to split it up because if you have an API key that were never intended to be used in this way, you have to change Gemini's way of doing auth. I think that's probably the way they should have done it from the get-go. Obviously, they did not ask Gemini to audit their code, make no mistakes. Let's see. I don't know if I really want to go over the CrowdStrike Global Threat Report. Let's see. Let me put that one as covered. This one, I need to research this so I can... And I'm going to put that as covered also. It was less interesting. Because it came from Bloomberg originally, there's like very few technical details in there. I'll tell you, let's go see what's over in the Bad Sector Labs blog. Who is this from? Oh, this was from Anthropic. So, if you didn't hear about this, Anthropic, who amongst all the other large language model creators is guilty of mass intellectual property infringement, was mad that someone was basically doing what's called a distilling attack on their models to go train their other models. So essentially sending structured queries to it, getting the data back, and making an input-output pair so that they could then go train their own models. And so they're like, you're stealing our IP. I was like, bro, you've just settled a $1.5 billion lawsuit over pirated material coming up in your language models. So yeah. Let's see. There was also Claude Code Security, which for some reason caused a bunch of completely unrelated security products to sell off, like CrowdStrike, Cloudflare. I was like, these guys don't even do secure code auditing. What did he say about this? So they said, is this the first AI-powered code review product for a major research lab? I don't think so. I mean, I think Google was already doing that with Sleep, I think. Or was it Deep Sleep? I forget what the name of it was. So there's been lots of third-party tools, but now Anthropic is offering it as a service. Maybe it can help with the Huntar. Your passwords and your entire ARR stack API keys are exposed to anyone on your network, or worse, the internet situation. What was that? I don't remember seeing that one. Today, after raising security concerns at a post in our Huntar regarding a lack of development standards in what looks to be a 100% vibe-coded project, I was banned. That made my spidey sense tingle, so I decided to do a security review of the codebase. What I found was not good. TLDR is, if you have Huntar exposed on your stack, anyone can pull your API keys from Sonar, Radar, Prowler, and every other connected app without logging in, gaining full control over your stack. That's funny. What is Huntar? It's now a private community because of that crap. Hold on. I gotta know what this is now. Didn't even go out. Hold on. What is Huntar? I'm curious about this. They privated the repo too. Let's see. What do the AI overviews say? Huntar is a self-hosted utility designed to automate the discovery of missing media and quality upgrades across all the AR applications like Sonar, Radar, Prowler, LiDAR. I don't know what any of these ARRs are. Continuously scans your media files, hunts for missing content, manages requests and swaps via Swapar, aiming to complete your collection automatically. I'm guessing this is something for sailing the high seas. That's funny. Oh, so Sonar is for TV, Radar is for movies? Oh, okay. Let's see. Oh, by the way, the guys who... I have not ever actually used Havoc yet. I've been meaning to, but honestly, I just really like Mythic so much. I haven't really messed with Havoc. But now Havoc Professional has come out. So they've released that. They've got some cool tricks in there. Let's go take a look at it. Because I need to get some more situational awareness around Havoc. Let's go to their blog. Here we go. Havoc Professional Release. By the way, the guy who's working on this, Paul Spider, he is incredibly sharp. And I wish I had probably half of his intelligence at his age that he has. Because I think he's 20, 21 years old maybe. And dude, at 21, I was still figuring crap out. Let's see. So since our last introduction blog post about the Havoc Professional Framework and the Kane Kit, we've refined the framework behind the scenes, added many necessary features that operators depend on to navigate hardened environments, while matching the capabilities of numerous concurrent competing vendors. Another major announcement is that we have a new team member joining us, Iker, who's been developing exciting new technologies and techniques for us for the last year since last September. Cool. Enhanced user interface design philosophy. Cool. I like a good user interface. Expanded DNS. So DNS over HTTPS and DNS over TLS. Nice. So they expanded the arsenal of covert communication channels, enabling for operators. Now, yeah, those are covert, right? But they're not difficult to detect.
What, your mom buy you a pewter for Christmas?
She did one year, because my mommy loves me. And now that's why I pay her bills. That's cool that they added doe and dot in there. Oh, what is this? Runtime channel switching. So a feature that's been introduced into Kane that allowed operators to dynamically update a session's listener configuration at runtime. Oh? What? So this capability enables an operator to reconfigure an existing session to connect to a new listener with updated parameters, allowing for seamless transition to fresh infrastructure and profiles that utilize clean domains. Ooh, Daddy likes. That's pretty cool. This effectively is pivoting away from a compromised or burned infrastructure without disrupting the session. Nice. Although if that particular C2 infrastructure you're using is compromised or burned, then yeah. Yeah. Let's see. That's a good idea too, Bob. I like that idea. Hey Gumby, if set that up for like 100 channel points or something, and then something where I can like try and track it. Nah, too, Bob, you're good, man. All right, let's see here. So what else did he say about this? Sessions can switch between entirely different listener protocols also, such as transitioning from HTTP to SMB or vice versa, regardless of whether or not the listener was configured as peer-to-peer or direct. Nice. Nice. Runtime channel switching also extends DNS-based protocols, allowing operators to seamlessly upgrade implants between DNS, DOH, or DOT. Now, that's actually pretty cool because what if you wanted to... Typically, if you wanted to do something like this, what you'd have to do is you'd have to have two different implants running on that system. One running, let's say, over DNS, which would be like you're just basically maintain your foothold. And then you would spawn a new one to do something like HTTP or TCP, something that has a lot more throughput so you could go back and forth with it. Have to have super mod privs. Okay. Remind me about that, and I'll put that in Gumby, because then also I can add it into a tracker. Let's see. Oh, this is also good because a lot of times when you're running these beacon object files, it blocks the execution in there. So, real quick, if you're not familiar with how this works, let's go clear this up real quick. We'll do this and we'll do this. All right, there we go. Fresh canvas. Beautiful. All right, so what happens here is in your victim computer, right here, right? So you've got this is your victim, your target, whatever. You got your C2 server kind of chilling down here. It's talking to the victim computer. And then inside here, you've got your agent running, right? So whatever your C2 agent is. So you've got a couple things that you can do here, and it's running inside of a process tree, right? So you got all these processes running in here. There's two ways you can do this. You can do something called a fork and run, where you actually spawn a new process to run some kind of like executable in there, right? This is actually really noisy and it's super easy to detect. So instead, what you can do is inside the memory of the process is you can set aside a piece of memory and you can load what's called a beacon object file. Another name for it is also a COF, Common Object File Format. What this is basically a tiny piece of code that whenever the program is going through and it's executing all of its lines of code, it can eventually say, oh, well, actually, we want to pass execution here. Let this code segment here run, and then it can return back and then continue its execution here. But the problem is most of these run synchronously, meaning the entire execution of the agent pauses while that BOF is doing its thing. So if you have asynchronous code down here, you've got this sitting here running and you don't have to wait for it to return. It can just continue on executing the instructions that it's got and just wait for that to finish, and then you can get your data back. So that's what an asynchronous BOF is. So synchronous, you got to wait for it to finish before your implant can continue executing, versus an asynchronous one where you can let it kind of run and do its own thing in a different thread. I'm not sure exactly what the implant particulars are, but that is something you can do with it. So the great thing about that is it doesn't hose up the rest of your implant while you're working on it. That's cool. I like asynchronous buffs. They're a lot harder to do over in Cobalt Strike. Ooh, what is this? Adaptive beacon object file. So another capability in the Kane kit file loader provides is the proxying and execution of Win32 APIs without requiring any call stack spoofing functions, using them directly within a beacon object file. So that allows existing object files from Trusted Sec, Outflank, and other developers to run naturally within the agent's current applied evasion capabilities. Ooh. Ooh. Daddy likes. Let's see. So they also have backwards compatibility and stable, extensions, enabled, embedded, and dynamic loading. So a key advantage of the built-in Kane kit is a collection of extensions that alter the agent's behavior by applying evasion capabilities at runtime or extending the agent with additional commands and features such as SOX proxy. Nice. Okay, cool. So it's got some extensibility to it. PowerShell? I like PowerSafe. So another feature introduced was PowerSafe, a modern approach to performing unmanaged PowerShell execution. So unlike traditional implementations like PowerPick, which rely on loading a .NET assembly to execute PowerShell scripts, PowerSafe takes a different approach entirely, executing PowerShell fully natively by resolving all necessary PowerShell execution environments, objects, and classes to prepare the execution environment while disabling all security features like AMSI, script block logging, module logging, transcription, execution policy, and constrained language mode. Nice. Constrained language mode is more of an annoyance than anything. Let's see. What about Firebeam? What is this? Since our announcement, we've had numerous iterations and ensure that it's working. It's easy to work with as possible. So our future goal is to port existing tooling over to Firebeam without any modifications or recompilations. As we work to this, okay. So what was Firebeam though? I think Firebeam is their virtual machine that they're shipping with it. Process of taking generated executables and transpiling them into bytecode following the following illustration. Yeah, this is I think their custom virtual machine that they're shipping out there. Nice. That's cool too. Let's see. Extensive support for existing tooling. So we wanted to emphasize that the blog that we value the R&D time spent by red teams to understand that not many have the privilege to either outsource or have an internal team. Hence, we've made it our mission to add extensive support for existing tools that will continue adding support for vendor-specific features and tools in the future by taking advantage of our own modular architecture. Ooh, nice. So for example, we provide additional support for beacon object files on older Windows systems without the need to recompile them from source with the necessary patches to function in legacy environments like Windows XP. Cool. So they added another extension to call stack spoofing. Nice. What else they got in here? Binary to binary obfuscator. Cool. So our approach seemed to... Hold on, let me read over this real quick. Oh yeah, so I've been meaning to play with Havoc, and I don't know how much of this is in the open source Havoc versus in the closed source one, but this is still pretty damn cool. So last year had me thinking about a way to address future static detections in our tradecraft. This was a problem worth solving to us because it seemed like the status quo was still sleep mask, and in some circles, byte replacements. Two fundamentally flawed approaches. One approach that seemed obvious at the time was to simply write our own LLVM. This is a link local virtual machine. What is LLVM again? Is it link local virtual machine? Oh, sorry, Gumby. Yeah, one sec. Yeah, this is just the release blog from it. I'm trying to remember what the actual meaning is. Is it link? Low-level virtual machine. I was way off. Yeah. Yeah. Thanks, Tubop. Let's see. Okay, so one approach that seemed obvious was they simply write their own LLVM-based obfuscator. However, we found that to be quite limiting. It simply isn't suited for our goal and ambition. So LLVM operates behind layers of abstraction that have no real concept of the final binary layout, such as relocations or offsets or final addressing within that binary. So the limitations on what can be done from within a pass will be the most direct, will for the most part directly trickle down into the need for an external script to patch things in. All in all, we felt LLVM wasn't the right foundation we decided to go with a custom binary to binary approach. Main function was raising the effort of writing static detections without compromising on size, stability, or runtime. So unlike commercial grade protectors, hindering analysis was secondary. Preserving the semantics of the original code was a hard requirement, as even the slightest mistake can snowball into undefined behavior. That's true. And you might have worked really hard to get that shell on that system, and it would suck to have it break because your obfuscator busted up your code logic. So we're actively working to establish collaborative partnerships with security product vendors to ensure our products cannot be misused by threat actors or malicious groups. Good luck, bro. That's unfortunately the name of the game, though. You come up with something cool, and then bad guys want to use it. That's just how it rolls. Let's see. This was another funny one, by the way. I'll just briefly touch on this. So the research team at Palo Alto is actually pretty good. Was it Unit 42, I think? Yeah, Unit 42 is theirs. And... oh, let me kill this part real fast here. Where are we at? Right there. You go away. So let's look at this. Palo Alto chose not to tie China to a hacking campaign for fear of retaliation from Beijing, sources say. So Palo Alto Networks opted not to tie China to a global espionage campaign the firm exposed last week over concerns that the cybersecurity company or its clients could face retaliation from Beijing, according to two people familiar with the matter. Now, I'll be honest with you, I really hate whenever they say this because I just don't trust a lot. So, oh, by the way, here you go, Guppy. I don't have any good articles about what Persona was doing, but for anybody who's curious about that, Persona was supposed to be what Discord was using for their age verification, but they have a lot of ties into the US government and open AI, namely ChatGPT, and nobody knows exactly what they were doing with all that data. So if you're curious about it, go read up on it. I don't have anything staged up for that, Gumby. Anyway, so back to this article here. I was saying I don't like according to people familiar with the matter because I was like, I want something more concrete than just, hey, an anonymous source said this. So the sources said that Palo Alto's findings that China was tied to the sprawling hacking spree were dialed back following last month's news. That Palo Alto was one of 15 US and Israeli cybersecurity companies whose software has been banned by Chinese authorities on national security grounds. Okay, so they're like, hey, we don't want to piss them off even though we're already banned in that country. Come on. So a draft version of the report by Palo Alto's Unit 42, which is their threat intelligence arm, said that prolific hackers dubbed TGR STA 1030 in a report published last week were connected to Beijing. The finished report instead described the hacking group more vaguely as state-aligned group that operates out of Asia. Well, you can damn well guess who that is. Attributing sophisticated hacks is notoriously difficult, and debates over how best to assign blame for digital intrusions are common among cybersecurity researchers. But Palo Alto has attributed hacks to China in the past. And the source told Reuters that Unit 42's researchers were confident, based on a wealth of forensics clues, that the newly uncovered hacking campaign was tied to China. The change, the source said, was ordered by Palo Alto's executives because they were concerned that the software ban were concerned by the software ban and feared drawing retaliation from Chinese authorities. You're already banned. What are they going to do? Double ban you? Let's see. The source did not identify which executives made the decision to soften the report's conclusions or provide precise language that had been in the report ahead of the change. They spoke on conditions of anonymity. Yeah, we know that. Asked to comment on alleged softening of language, Palo Alto issued a statement to Reuters that said that attribution is irrelevant. Not really. I mean, it's difficult, but it's not irrelevant. Oh, so TGR STA was threat group state aligned. That's funny. So anyway, I'm not going to go into the rest of this. Just know that Palo Alto tucked tail because they didn't want to appear bad to somebody who's already banned them. Hold on one sec. Let me take a look at this real quick here. Oh, you know what? I saw this too, Bob. Yeah, let's take a look at this real quick because this will be a fun one. Man accidentally gains control of 7,000 robot vacuums. He just wanted to steer his DJI Roomba, or Romo, with the gaming controller. Oh, DJI. Let's see. So a software engineer's earnest effort to steer his new DJI robot vacuum with a video game controller inadvertently granted him a sneak peek into thousands of people's homes. So while building his own remote control app, Sami Asdufal, I don't know if I'm probably saying that wrong. But anyway, reportedly used an AI coding assistant to help reverse engineer how the robot communicated with DJI's remote cloud servers, but he soon discovered that the same credentials that allowed him to see and control his own device also provided access to live camera feeds, microphone audio, maps, and status data for nearly 7,000 vacuums across 24 countries. Oh man. So the backend security bug effectively exposed an army of internet-connected robots that, in the wrong hands, could have turned into surveillance tools, all without their owners knowing. Claude aiding and abetting again. I know, right? Wait, hold on. He just said AI coding assistant. There are other options. That's just the most popular one. By the way, I'm going to put on my my tinfoil hat here just a little bit. And note that, by the way, DJI has been in hot water with the US already because of some of their stuff, and they are based out of Shenzhen. So, yeah, this might have not been such an accident. Let's see. So, luckily, Asdufal chose not to exploit it. Instead, he shared his findings with The Verge, which quickly contacted DJI to report the flaw. While DJI tells Popular Science the issue's been resolved, the dramatic episode underscores warnings from cybersecurity experts who have long warned that internet-connected robots and other smart home devices present attractive targets for hackers. Well, yeah. Obviously. As more households adopt home robots, including newer, more interactive humanoid models, similar vulnerabilities could become harder to detect. AI-powered coding tools, which make it easier for people with less technical knowledge to exploit software flaws, potentially risk amplifying those worries even further. Oh, good. This guy, he said, I can finally confirm that DJI has finally fixed the huge vulnerability they had in their servers. So how did he stumble into this massive security hole? So the robot in question is a DJI Romo, an autonomous home vacuum that first launched in China last year and is currently expanding to other countries. Retails for around $2,000? What? I gotta take a look at this thing. This thing's $2,000? Dude, you could have got a GPU for that. A small GPU, but you could have got a GPU. Or you could have got 32 gigs of DDR5. That is a fancy looking robot though. Why is this thing $2,000? Holy crap. There's no reason why my refrigerator needs to be connected to the network. Word. I was thinking about making something, Gumby. I thought about starting my own company, and its sole purpose was going to be to produce dumb tech with zero networking capability. And so I was thinking about calling it the Dumb Tech Foundry, or DTF. I think everybody will love being DTF. Let's see. Okay, sorry, I got a little sidetracked there because it said it was $2,000 for a robot vacuum. Good God. Let's see. So, like other robot vacuums, it's equipped with a range of sensors to help navigate its surroundings and detect obstacles Users can schedule it via the app, but is designed to spend most of its time cleaning and mopping autonomously. So in order for the Romo, or really any modern autonomous vacuum, to function, it needs to constantly collect visual data from the building it's operating in. It also needs to understand specific details about what makes, say, a kitchen different from a bedroom, so it can distinguish between the two. Some of the sensor data is stored remotely on DJI servers rather than on the device itself. So for Asdolf's DIY controller idea, he would need a way for his app to communicate with DJI servers and extract a security token that proves he's the owner of the robot. Rather than just verifying a single token, the server granted access to a small army of robots, essentially treating him as the respective owner. And that slip-up meant Asdolf could tap into the real-time camera feeds and activate their microphones. He also claims he could compile 2D floor plans of homes the robots were operating in. A quick look at the robots' IP addresses also revealed their approximate locations. None of this, Asdolf insists, amounts to hacking on his part. It simply stumbled upon a major security issue. DJI identified a vulnerability affecting their home, DJI Home, through internal review in late January and initiated remediation immediately. Issue was addressed through 2 updates, with an initial patch deployed on February 8th and a follow-up one patched on February 10th. The fix was deployed automatically and no user action was required. Oh, that's funny. What else do they have in this? That's about it. The rest of it is just like talk about social media or homeowners grappling with privacy cost of a smart home. Yeah, there's a lot to it. That's funny. It better really suck for that price. Hey, Ken coming in hot with the dad jokes. Oh, look at this. They're now doing click fix for... They're now doing click fix for Mac. That's funny. So ClickFix has quickly become... so if you're not familiar with what ClickFix is a thing like you visit a website and it pops up saying, hey, by the way, we detected malicious activity from your network and we need to validate that you're actually a human. So go open a terminal and paste this command in. And the command looks rather innocuous. However, when you click that handy little copy button, it doesn't copy the text that it shows you that looks like an innocuous command. It actually copies a big long string that's basically going to do a download and exec of some kind of malware onto your system. So that's what ClickFix is. It's mostly a social engineering method. My sister has a microwave that connects to the network. No. But she's not tech savvy enough to get it to connect, so I told her not to. That's right. Just don't. Just don't. Let's see. So ClickFix has quickly become a widely adopted infection technique targeting both macOS and Windows users. Rather than relying on a software vulnerability or exploit chain, it leverages something simpler, convincing a human to copy and paste a command into the terminal. The mechanics are straightforward, yet the impact is significant, allowing attackers to bypass OS-level protections such as gatekeeper and notarization on macOS. The technique is now being leveraged not only on opportunistic cybercriminals, but also by more sophisticated threat actors. As its adoption increases, it becomes important to examine practical ways to reduce the effectiveness. So this is what it looks like right here, right? It looks like something like really chill. Oh, in this case, it does not look chill, right? Pasted to the terminal detected. A website may have tricked you into copying malicious command. Please review. Ooh, block. What is block? Let's see. So a couple of notes. Full source code of this implementation will be found in block, which is up on GitHub, which includes this protection. The approach covered here is simple and largely effective. However, as with any defensive technique, there are limitations and potential bypasses. Okay. So background. ClickFix seems to be all the rage, currently one of the most in vogue infection vectors targeting Mac and Windows. But what is it? It's a social engineering technique that tricks users into copying and pasting attacker-controlled commands into a terminal, therefore executing malicious code. Let's see. So recent examples. First, most recently, researchers at MacPaw's Moonlock Lab. I love these names. MacPaw's Moonlock Lab uncovered large language models natively propagating clickfix style attacks to unsuspecting users. Hold on, I gotta look at this real quick. Oh, that's hilarious. So they poisoned the language model. Oh, that's so bad. Oh, no. Okay, so I take it back. So what they were doing is they did have the language model come and spit this out, but then they were sharing this as a chat. So you can share your chat interactions, right? And then they were sharing that. Oh, that's funny. No, Gumby, I don't want to warm up water from my phone by connecting my microwave. Let's see. All right, so if the user trusted the language model and followed the instructions, the basic 2 encoded payload would be decoded and used to download and execute a maxing stealer. Nice. That's funny. The Moonlock researchers also uncovered another vector in the same clickfix attack. Searches for macOS utilities related to disk space led to an article masquerading as an Apple support team, again, including user information to go download and run this. No. It should be legal to just like lock the terminal if you don't know how to use the computer well. Oh, that was for a hot tub? All right, that is kind of cool. Let's see. So another clickfix attack being discovered this month was from Google's Mandiant team. They noted that North Korean nation-state actors engaged victims and enticed them to join a virtual meeting with the prominent CEO. Once connected, they impersonated CEO, claimed the victim's computer was experiencing audio issues, and directed them to run a troubleshooting command on their system to resolve the problem. No CEO is going to tell you, hey, go run this command. It'll fix your audio, jippity split, quick, fast, in a hurry, no cap. They're not going to say that. That's not what CEOs do. CEO's going to be like, hey, let me call you from my phone. And they're going to call you and they're going to be like, hey, order me Apple iTunes cards. I've been around enough CEOs to know they fucking love Apple iTunes cards. Do you use a lot of JavaScript injection into websites in your attacks? I use that all the time and missing stuff to cite that I want via bookmarks that I write. Do I use a lot of JavaScript injection on a web page during my attacks? Not particularly. I mean, there's some, like if we're doing a phishing campaign, yeah, there's going to be some JavaScript injection happening in there. But for the most part, like I'm reading that as if you're talking like if I was attacking a web app. So, or to create transient tooling. Not particularly. I don't get a lot of call for phishing campaigns anymore. Yeah. There's a ton you can do with that. And when I was using, what was that tool? I can picture the guy's name. I can't remember the name of the tool. Evil Jinx. When I was using Evil Jinx a lot, yeah, there was a lot of JavaScript injection and other shenanigans I would put into there. But for the most part, I don't have to a whole lot. Let's see here. So going forward with this, they say, though it's tempting to dismiss ClickFix as simplistic, that would be a mistake. So as shown above, these attacks are widespread and impactful, enabling cybercriminals and nation-state actors to infect user systems while neatly sidestepping OS-level protections. Let's see. However, the very simplicity of the technique presents an opportunity. Because ClickFix relies on a user-initiated copy and paste into the terminal, we can attempt to generically disrupt it by detecting paste into terminal applications, because those that originate from, particularly those that originate from web content. So in this section, we're going to explore the detection heuristic. Cool. Let's see. First, it's important to note that a core commonality across most, if not all, the ClickFix attacks is they rely on the user pasting a command into the terminal. So if we can reliably intercept the paste operations into the terminal application, in theory, we should be able to generically disrupt the majority of these attacks. I mean, that makes sense because essentially every time you open like your terminal over here, right? If I can get it to work. Here we go. So over here in your JavaScript console, right? Over here, if you've never messed with this and like you come in and try to like paste something, I'm pretty sure I've already done it. Yeah, there we go. Warning. Don't paste code into the DevTools terminal that you don't understand. And you have to manually go in and enable it. You have to actually type in the command allow pasting, right? So you would type that in, allow pasting, boom, and then you could go through and do it. I'm not going to do it because I have no reason to do it on here, but that's essentially what you have to do. So you could do something very similar over in your terminal. You know what? Actually, too, Bob, you just reminded me. I did do a JavaScript injection on exactly one tool with a bookmark. It's a reporting tool that originally was not a reporting tool called PlexTrack. And PlexTrack had some very annoying UI behavior. And so as I would go through and I would use it for writing report when I was at my last company, and they've since moved off of it, so I don't care about talking about it now. But it would come through and it had like all these markdown fields that you could come in and you could expand them and you could collapse them. And it was such a pain. So I had an iffy function embedded in a bookmark. So that way I could just come over to my bookmark tab, click it, and it would just collapse all of those. That's all it did. It just collapsed every single one of those text fields so that I could just expand the one I wanted because it was my entire report essentially in there. So if I wanted to go all the way down, it was such a fucking scroll fest. I hated it. Oh, let's see here. All right, so how were they doing this though? So that's one thing to do it over in the terminal there. So to detect into the terminal, we needed to detect a pasting, which is Command V. Determine whether the destination of the paste is a terminal application, and if so, intercept the paste and alert the user. So it may be tempting to improve this approach by attempting to track whether the paste originated from a browser. However, some click fix attacks originate from chat applications or an email, so relying solely on a browser attribution would be insufficient. And that's true. Let's see. So in macOS land, we can leverage the NSE events class, and that method can detect when basically Command V is pressed. And by going a little bit further, let's note the global event monitor rightfully acquires accessibility permissions. So the call code snippet from block allows us to see the code permissions. Very cool. So what they did is they basically put in a little bit of a listener that says, hey, if you're pasting into a Mac terminal, kill it, get it out of there. Let's see. All right, very cool. I like the idea here. Hold on, let me see what their limitations are. If a user pastes click-fix commands in the terminal via right-click paste rather than using the keyboard shortcut, this implementation won't detect that action. However, most observed click-fix campaigns explicitly instruct the users to use the keyboard shortcut. Okay. Very cool. Interesting idea there. Good old click-fix. Let's see. Oh, is this the one? Oh, no. I don't know what it is about the SpectreOps blog, but every time I open DevTools, it grinds to a halt. I'm gonna have to message them about that. Because all I want to do is delete this header, because this header takes up 15% of my screen real estate. That's my bookmarks all over. It's the tool menu for the web. Nice. My company got acquired last year, so now I'm having to use PlexTrack. My condolences, Ken. Because... Can I delete? Go on, delete element. Every time. Actually, I think it's this one that's one I really want to delete. Look at that. It just hoses up my browser every single time. Use vertical tabs? I think I want to undo that. Exit page. Don't use vertical tabs. Go back. Oh, yeah, sorry. Forgot to drop the link over here. 1 second. There we go. There's the link for everybody. Let's see what happens here. It's still there. All right, there we go. Have to use Brave's block element. All right, cool. Now I get my full screen real estate back. All right. So this one is mapping. This will probably be the last one we cover for tonight. This is by Josh Prager, who is a big-time mega brain detection engineer for Spectre Ops. So when it comes to like crafting up detections and looking at how to leverage like current detections in your network, he's just a freaking galaxy brain. And so he wrote this. He told me he was writing this. Mapping deception solutions with Bloodhound's Open Graph. Use it for configuration manager. Nice. The deception, the betrayal, man. You deceived me. If you've not seen this movie that this meme is from, go watch it. It's a little movie called White Girls with the Wayans brothers. Go watch it. It's fantastic. All right, so the TLDR here is at Spectre Ops, we look at attack path management from multiple perspectives, including those of identifying areas to implement quality deception solutions. So in this blog, I discuss identifying key areas for configuration manager infrastructure that defenders can implement for deception solutions. Additionally, I provide practical examples of mapping those key areas in Open Graph using Chris Thompson's config man bear pig. I love that. And also Ben Schroeder's deception clone projects. So for the methodology is, as a consultant, I've had several opportunities to work on deception solution projects for both the private and public sector. From my experience, the most effective implemented deception solutions take advantage of existing attack paths that adversaries would find attractive to achieve their objective instead of introducing randomly placed canary accounts or files. The blind spot many randomly placed canaries contend with is the fact that actual adversaries typically achieve objectives with as few steps as possible. And I've seen APT groups elevate from local administrator on an externally facing SharePoint server to domain administrator by simply dumping the credentials from interactively logged on domain administrator accounts managing that SharePoint server. So from that point, the adversaries use the stolen credentials to laterally move to the domain controllers and dump NTDS, which is basically a database of every single hash for every user in the environment. And then once you have that, you even get the curb TGT hash, which is essentially the signing hash for everything in the environment. You can write your own tickets. It's game very over at that point. So the has session attack path is already presented to the adversary, and they leveraged it. In this scenario, it did not make any sense for the adversary to hunt around for a passwords.txt file living on a file share somewhere. The canary file was not attractive to the attacker and didn't blend in with the environment well enough to be considered an adversary's objective. So during deception solution program development for some clients, we at Spectre Ops consider deception solutions to be effective when several attributes about that deception solution are satisfied. Blends, designed to integrate naturally into the environment. Oh no, damn it! I clicked the link. There we go. Okay. So back to this. So it has to blend into the environment. It has to be attractive. Attackers can identify the solution, and they'll want to. And it needs to introduce no new risk, and it needs to be high fidelity. Accessing it is reliably detectable. So it does no good if you've got, a pitfall in there that you can't get a notice about, right? So Ben Schroeder wrote Mapping Deception with Bloodhound Open Graph, which dives deeply into Spectre Ops deception solution development methodology. I provided a high-level overview of that methodology, so I'm not going to spend more time discussing it. Instead, let's shift our focus to areas where we can leverage Configuration Manager as a deception solution implementation, which this is very timely because the last internal penetration test I was on, we owned all 3 of their domains through SCCM. And in fact, one of the domains we had like domains A, B, and C. And in one of them, we actually jumped from domain B back to domain A to compromise their SCCM, to then jump back to domain B to compromise that domain. So we were just able to loop around in there. It's Configuration Manager SCCM. It's a notoriously difficult to configure and harden system. So using OpenGraph, defenders can leverage Bloodhound's OpenGraph to map the deception solutions implemented in their environment for the purpose of planning and tracking. We released Bloodhound OpenGraph at Black Hat in 2025, and the capability is available in both community and enterprise versions. The OpenGraph capability enables organizations to map anything into a graph form. And I really do mean anything. Our adversary tactics and detection course has students generating endpoint detections and response telemetry models using Bloodhound's OpenGraph. Bloodhound OpenGraph intended use case is to enable organizations to map enterprise environment data beyond Active Directory and Intra to things like third-party services and applications. So for example, OpenGraph opens the capability to connect the dots between Active Directory and users with GitHub access models, and from GitHub access models to AWS secrets. So the organization can now graph access models across multiple disparate and seemingly separate technologies within their environment. Let's see. Currently, there's also the OpenGraph Community Incentive Program, which enables the community of participants in mapping unique applications and identity providers for a chance to attend SoCon in 2026. Ticket, flight, and hotel included. So, if you like thinking with graphs, go check that out. So as a particular example of mapping deception solutions into OpenGraph, defenders can leverage Ben Schroeder's Deception Clone project to modify the attributes of OpenGraph nodes to display implemented deception solutions. So throughout this blog, I'm going to show both examples of that deception solution before and after the Deception Clone project modifies the code. Radioactive. Love it. All right. I love Config ManBearPig. This is a fun tool. Chris Thompson released Config ManBearPig to map SCCM infrastructures within an organization environment. And I did use Config ManBearPig on my last internal pen test because, like I said, we took heavy advantage of their SCCM environment to do the escalations. The tool generates JSON data that Bloodhound OpenGraph can ingest to map the existing edges between the infrastructure that enables traversal of the misconfiguration manager attack paths. Let's see, it's a Bloodhound collector that uses LDAP to collect site servers by identifying objects with a full control of the system management container. It also collects primary site information where the object class displays MSS site. So there's very clear indicators of what each piece is doing. And the collector will continue to enumerate the SCCM infrastructure and find managed endpoints, central administration sites or the CAS, and also SCCM client devices. Let's see. More information, go see his blog post about it. All right. So what about ConfigMan deceptions? Configuration Manager has been targeted by offensive research lately. With the creation of SpectreOps Misconfiguration Manager project, offensive operators have begun to leverage a client's endpoint management infrastructure to execute scripts and deploy payloads. Configuration Manager is a very valuable target to adversaries because of the administrative capabilities that Configuration Manager infrastructure holds over every endpoint within the site. So one of the things we saw during our last assessment was that domain controllers were managed by Configuration Manager, or SCCM, or whatever the hell they're calling it these days. Microsoft cannot get their verbiage correct. But anyway, so once we had compromised SCCM, then it was a very simple hop to just get onto the domain controller. So easy peasy lemon squeezy. SCCM is comprised of multiple key pieces of that infrastructure that enable administrative capabilities on every endpoint within that site. So for an infrastructure and how to view the nodes in OpenGraph, take a look at Chris Thompson's blog. Yeah, we got that. All right. First deception solution, a Canary NAA account. So if you're not familiar with what NAA is, that's a network authentication account. And it's basically a very basic account that is used for whenever Configuration Manager gets onto, or a system enrolls in ConfigMan, it needs something to be able to operate and to configure that system. That's what NAA does. And a lot of times those accounts are very highly privileged. So getting a copy of the NAA account or even the hash is very nice. So in here, he says on the article, site distribution points are the client-facing content servers used to host content that a client can retrieve and execute. Site distribution points are often targeted by adversaries because of their pre-boot execution or pixie boot media hosted for the clients who are joining the environment for the first time. So management points are the client tasking servers. Clients will send periodic messages to the management point to check in and request any updates as per whatever the client policy is. Yeah, here we go. So here's our two machines right here. Mayhem. So per the CRED1 technique from Configuration Manager, Pixie media is distributed from the site server to the distribution points when non-domain joined clients can use TFTP for this. So anything that can talk to it over TFTP, which is an unauthenticated protocol, goes over UDP, you can pull that down. Once you've got the boot media, there's usually credentials listed in there. So the process can be abused because the files and policies accessed without booting the Pixie media. And so doing a DHCP discover request, by the way, this TFTP server, you figure out about it from DHCP. It tells you like where it is. So via a DHCP discover request, attackers can discover the distribution point and download the boot media. The boot media is encrypted via a password, and Hashcat can be used to crack and recover the hash of the password. I believe the boot media is encrypted via a well-known password, if I remember correctly. I think it's a well-known static password. Don't quote me on that. But anyway, once the boot media is decrypted, the attacker may be able to identify an NAA account. I doubt Josh would have made an error here, so that's probably not the case. But essentially, it's supposed to be protected. It's not. The NAA is a domain account that is typically configured on that site server. SCCM site clients use that NAA account to access and retrieve software, updates, and policies and apply them. The NAA is often overprivileged to offer I can't talk. So the NAA account is often an overprivileged account and have historically seen the accounts with admin 2 rights over all workstations, SCCM admin accounts, or even domain administrator accounts. And the domain account is stored on every SCCM client. So attackers abuse the legitimate flow of a Pixie media and the NAA to obtain domain credentials for lateral movement. Config ManBearPig doesn't collect the node and edge relationships of NAAs because the collector cannot guarantee that an NAA credential is valid. However, from a deception solution, we can implement canary NAA credentials and model that relationship in Bloodhound OpenGraph by manually editing the config ManBearPig JSON. So here what he did is he basically made a self-referential loop saying that PS1 here has an NAA account in it. A NAA account. So this deception solution is documented in Canary 1 in the misconfiguration project. Defenders can create a Canary NAA account by creating a new user in Active Directory using a similar naming convention to other SCCM related services. And the deception solution can then be used to detect adversaries using open source SCCM tooling to enumerate or steal the credentials of that account. For example, Adam Chester's SCCM WTF. I love security tool names. All right, over here. So the range I'm using for this particular setup example is different from the sample data range from the config ManBearPig project that I'm showing in the OpenGraph screenshots. So upon a DC run, or DSA, create a new NAA account within Active Directory, add a realistic description to the account. You want it to look real, right? Set the password to something that looks realistic, 16 random characters. Don't worry, because we're going to reset the password. That's a key part here. You don't want to go set it up and make it look attractive and then not cycle the password. That's a big no. So once the account's been created in Active Directory, you set up a server ACL. I forget what SACL stands for. Something access control list. What is a SACL? Hold on. A system access control list. That's it. And basically, and then once you set that up in the security tab, you go to the advanced button, go to auditing, add it, boom. So you add that principal to it. So on the auditing tab, pop it up, you get the principal name. So you go through how to configure all of this in here. Let's see. So for the principal audit, select everyone, click OK. And for the type, you to drop down and select all, and then you give it these particular permissions. So you're going to make this look like really nice in here. So to create the effective deception solution, defenders can edit the account to restrict interactive logins and avoid creating a new exploitable attack path. So then he goes through the options like, hey, here's how you disable interactive logins for that particular user account. And then so to ensure this account cannot be misused, you have to make sure it's got two primary configurations on it. The password never expires and the user cannot change the password. That way they can't come in and basically say, oh, the password expired, and they can force a password change on it. So you're blocking that ability into it. So once that account's been created and the SACL has been set on the account, you log into Configuration Manager, you go through the setup for that. Super important, seriously, don't skip this step. So once you create the account in Active Directory and you add it to SCCM, you're going to want to rotate the password of that account to a new random 64-bit character, something else. Because now that's a live password that's been captured in SCCM, but it doesn't ever sync to Active Directory back and forth. It's a one-time deal. Once that's done, it's done. It assumes that password's never going to change. So then you go into Active Directory, you change that password, and you've broken the link there. But what you now have is you've got a password that once they come in and they try to grab it and it looks all legit, then boom, as soon as they use it, they get caught. Just like that. So we can model the canary with the Bloodhound Open Graph by utilizing the clone deception script and insert a custom edge to the distribution point, just like this. So what he's saying is, hey, by the way, this computer here has this deceptive token in here. I love that I wish he had chosen biohazard instead of radioactive. I think that would have been more appropriate, but you know what? It's fine. It's fine. So let's see. What about in the Pixie media? So in large environments where multiple distribution points are deployed, defenders can designate one of the distribution points as a Pixie media server. So what's supposed to happen? Let's cover this real quick, because in case anybody doesn't know what's supposed to happen. So you have a network boot option on your computer. So typically, if you've ever gone into the BIOS and looked at it, your computer has multiple boot options. You can boot off a USB, you can boot off of some kind of stationary disk in the computer. You could also, back in the day, boot off of CD or DVD. But there's also one in there called a network boot. And that's what Pixie was really designed for, where it would boot, it would do a DHCP resolution, and then once that happened, you'd have that DHCP discover message come back. That DHCP server could actually send back information about the, about the TFTP server and how to go download and get bootable media. So then it would download it over the network, load it up into memory, and bam, boot off of that. Yeah, Pixie is proper OG stuff. So it was designed as a way for administrators to like bootstrap their systems and get them up and running without having to go through the USB or CD or heck, even back in the day, floppy disk, like dance of getting an operating system installed on the system. All right, so back to the article here. The distribution points that are serving that Pixie media will typically have a remote install directory and SMS temp share accessible, basically to everyone. Yeah. So defenders can replace the existing legitimate Pixie media with the Pixie boot file structure from a lab environment, and from the perspective of an attacker, it would be very difficult to determine if the Pixie boot media stored was legitimate or fake without accessing and enumerating the ACLs to determine that the SACL was set on it. So now you've got two, You've got two canary deception methods going on here. One is the NAA account, which doesn't do anything. You've also got the Pixie media in here. So defenders can enable auditing of the SACL on the fake Pixie media to determine access attempts to these files. Additionally, the distribution point server with the remnants directory, defenders can enable the detailed file share auditing. So there's lots of different, basically, tripwires you can go ahead and put in here. Hang on one sec, guys. All right, I'm back. Had to blow my nose real quick. I need to clean my office. It's too dusty. Again, what, Rabbit? What? What again? What? All right, let's see here. I wasn't pooping. That would make me literally the fastest pooper in the West. Let's see. So here he's talking about more like, I'm not going to go into all the details of like how you actually go through and set up the tripwires with the different file level auditing and event IDs. Just know that they're there. Let's see. Okay, so since this member server is used as a deception solution, the volume of logs accessing the share should be relatively low. And so, for example, he shows this particular event ID 5145 will show up if you're running Pixie Thief, which is a tool designed to go through and download stuff off of a Pixie server, off of a TFTP server. I think this one in particular was designed for phones, though. That was the initial usage of it. Oh, no, I take it back. This was specifically designed, it was dropped at DEF CON 30, so it was about 3 years ago, for pulling down the stuff from Config Manager. So Pixie Thief was specifically for that. There was another one. I'm trying to remember. I think it was from the guys at Trusted Sec. What was that one called? But it was for... Well, it was for a VoIP system from Cisco. What was that called? CUCM Thief. That's it. Was it CUCM Thief? No, that wasn't it. Maybe it was. Yeah, it was. I got it right. CUCM Thief. Yeah. I used this one. I used this one to compromise an entire organization for a retailer that I guarantee every single one of you has been into their stores. Yeah. Yep. This was a fun one. Oh, good old Cisco VoIP. I actually went through a Cisco VoIP course and refused to sit for the certification because I was afraid somebody was going to see that I knew the information. They were going to make me do it. Almost all mammals take 20 seconds to pee. On average, yes. But I also have to have travel time, too, Bob. I got to have time to get to and from the toilet. I'm not living that neat life. I don't have my piss jugs just down here lined up next to the desk. No, 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 no. Sock would not stand for that. She puts up with a lot of my crap, but she will not put up with my literal crap. The Texas catheter. Oh no. I love that you can use Texas as an intensifier, right? It's like you just name anything and then you call it the Texas version of it, and you know it's just whatever the original item was times 10. I love the Texas intensifier. Let's see. All right, so going back to this here. So we're still talking about the Pixie media. Defenders can utilize the Deception Clone project to clone a selected distribution point serving the Canary Pixie file and mark the distribution point as a deception solution within Open Graph. So easy peasy, lemon squeezy. There's another solution here, which is the SC user account table. So when discussing proposed SCCM focused canaries, Chris Thompson mentioned his use of the SC user account table in the SCCM database. By the way, SCCM is just basically a giant database also. I wasn't familiar with the MySQL database table and other sensitive tables. So while multiple techniques with Misconfiguration Manager project discuss enumerating or harvesting credentials from SCCM related accounts, the CRED5 technique in Misconfiguration Manager provides the most explain it like I'm 5 version of the intended use of the table and the abuse techniques related to it. So I'm going to paraphrase. So this particular account, SC user account, for the Microsoft SQL database table, contains the credentials for all the different SCCM accounts used for various purposes, including network access, domain join accounts, client push, everything. This table contains username and password pairs as hex-encoded RSA private key encrypted blobs. The table also contains the SCCM site's SCCM account credentials, and the username and passwords could be enumerated from the site due to basically a sysadmin role over the database. Additionally, With the site server's private key, an adversary can decrypt that credential blob. Garrett Foster's SCCM Hunter can enumerate the account of the SCCM user account table and recover the stored credentials via the decrypt command. So, like I said, it's pretty straightforward. SCCM Hunter doesn't actually use the site server's private key directly, but instead invokes SCCM's own cryptographic API. It indirectly uses the private key by uploading a script to the SCCM and leveraging the run script execution capability to load this guy, this SCCM decrypt function. So defenders can stage Canary expired credentials within that database and leverage by using the NAA account created from Canary 1 technique. So if you're thinking, what does he mean by expired credentials? That's the best way I can explain it. It's not a bug, it's a feature. SCCM will also store the credentials of a service account at the time of configuration and will not continually validate the credentials against Active Directory. That's what I was talking about earlier, is that basically once they're set in there, SCCM's own expectation is that they never change. So he's abusing that for this Canary. So while probably annoying for an SCCM administrator, this is perfect for a deception solution by ensuring that if an account is stolen, the credentials don't work. If you don't skip over the seriously important step from above when creating the NAA account, then you've already addressed the issue with that Canary account in your SCCM config. So basically, you create the NAA service, set a SACL on it in the SCCM console, add the Canary service account, and then go back to Active Directory and change the password. So you're breaking the linkage there, but you still now have a account that nothing should ever authenticate to. And as soon as anything does, it's like a spotlight on your network just pointing down on them, assuming you've got your detections dialed in. So I'm a big believer in trust but verify, and if you're like me, you'll want to do the same thing. So SCCM Hunter has an admin module that you can run to get creds command and validate the password set for the Canary token. So after running get creds, we can run the decrypt command to validate the credentials are set to the original poor password. Password 123. Yeah. So like with our other deception solutions, we can add that Canary NAA account over to OpenGraph for tracking and planning. And like the distribution point, config manbearpig, I love that name. Config manbearpig, it's so good. Anyway, config manbearpig doesn't display a traversable contains NAA edge by default, but you can add it in there. So this is a custom edge that gets added in where this node is both the source and the destination. So the final step in creating an effective deception solution is ensuring the solution is reliably audited. So defenders can audit the Canary account upon enumeration and credential abuse by malicious actors by centralizing the previously mentioned SACL events and collecting it in here. So then he goes through all the steps of like setting that up. I'm not going to go into the details of it, but essentially that's the main thing. Me giving bro the best advice ever, but adding, but I don't know though, just in case it ruins his life. So, but that's basically it. So that's what the whole point of, and I think these are going to become increasingly important with a lot of the stuff that we already saw about a lot of the like automated AI attacks that are coming up, right? Because if you just let that sucker run, then you can make very enticing attack paths that look legit but are actually traps to catch these folks in your environment. I think deception engineering is going to be huge going forward. All right. Unfortunately, guys, that is where I've got to wrap it up for tonight. So let's go see if anybody's over on InfoSec streams. CyberDoc is on. Let me see what he's working on tonight. Is he working on anything cool? What's he doing? He's doing some try hack me. You know what? I think we will go right over to him. He's doing some fun stuff. Dude, you got a Cisco Catalyst 4500 series network tower with a 48 gig backplane for $100 at auction. Ooh, yeah. That's some old stuff in there. All right. Yeah, we're going to go right over to CyberDoc. Do me a favor, guys. When you get over to CyberDoc, drop a bunch of Hack the Planets in the chat for him. Hack the Planets and emotes. Show him some love. He's working on learning cybersecurity right now, so we're going to show him some encouragement. All right, think we got that all set up. Alrighty, guys. Unfortunately, that's where I've got to wrap it up for tonight. Woot. Thank you all for coming to hang out for a new stream. I missed you guys last weekend, but I was just dead tired. We'll keep up with our projects coming up on Saturday. So I will catch y'all Saturday and Sunday night. And remember, the week is not over. So we are still in Crushing It mode. Crushing It mode is in full effect for another 2 days. Do remember, though, there's a catch on Friday. Friday is read-only Crushing It mode. Do not push to production if you value your weekend at all. You need to have some recoup and recovery time, get away from the screens. And I think that's everything I got for you guys. I think that's it. Yeah, that's it. All right, guys. I will catch you up with y'all on Saturday. Everyone, y'all have a fantastic rest of your week. And remember one very important thing, which is... good night. I saw that one come in. I had to catch it real quick. Everyone, y'all have a fantastic rest of your week. I'll catch up with y'all on Saturday. And I want y'all to remember one very important thing, which is I love you. Peace.